Hello there, and welcome to Just About Earth, where curiosity gets comfortable, science slows its breathing, and big questions are allowed to unfold at human pace. This is a place for wondering without rushing, for learning without strain, and for letting the mind wander gently while the body rests. Tonight, we're settling into a question that has been quietly waiting at the edge of textbooks and timelines for a very long time. Patient, unresolved, and strangely familiar. Human history, as we're usually taught it, feels neat enough on the surface. A long climb from stone tools to satellites, from cave paintings to computer chips. Dates line up in orderly rows, arrows point forward, progress marches on. But every so often something doesn't quite fit. A detail appears where it shouldn't. A discovery arrives too early. A structure stands in the wrong place in time, and instead of rewriting the story, we often just turn the page quickly, hoping no one notices the missing paragraph. Tonight's journey is about that missing paragraph, the lost chapter of human history that science can't fully explain. Not because science has failed, but because evidence sometimes arrives before understanding does, because data can outpace theory, because the past, like the Earth itself, does not always reveal its layers in neat chronological order. Before we drift further, take a moment to notice where you are. Where are you listening from right now? Is it late evening, early morning, or one of those quiet hours that feels detached from clocks altogether? Maybe the room is dark except for a small light. Maybe there's a familiar hum in the background, a fan, distant traffic, or nothing at all. And what brought you here tonight? Curiosity, restlessness, habit, or simply the desire to let your thoughts slow down without going completely still. If you find this space calming, intriguing, or simply a gentler way to end your day, you're always welcome to like the video or subscribe. It helps this small, quiet corner of the internet find others who might need a slower pace too. No pressure, just an open door. Now, let's ease into the story itself. History, as a discipline, depends on sequence. One thing happens, then another. Cause, effect, development, refinement. That structure is comforting because it mirrors how we experience time in our own lives. Childhood before adulthood. Morning before night. But the Earth does not experience time the way we do. Layers of sediment compress centuries into centimetres. Catastrophes erase generations in moments, and sometimes human activity leaves marks that outlast the people who made them, waiting tens of thousands of years to be noticed again. When archaeologists and scientists reconstruct the past, they rely on patterns. Tool styles evolve gradually. Settlements grow more complex over time. Agriculture follows foraging. Writing follows cities. These patterns work remarkably well most of the time. They explain the rise of known civilizations and the spread of technologies across continents. They give us confidence that we understand the general shape of our story. But then there are anomalies, objects found in places that don't match their age, structures whose construction techniques seem out of step with the tools available at the time, traces of human presence that predate accepted migration timelines. Not one or two, but enough to form a quiet constellation of questions scattered across the globe. These are not the kinds of things that shout. They don't announce themselves as revolutions. They appear slowly, often decades apart, sometimes dismissed at first as errors, contamination, or coincidence. And in many cases, those explanations are correct. Science is careful for good reason. Extraordinary claims require extraordinary evidence. Most mysteries shrink under closer inspection, yet some don't. Some linger. Consider how much of human history is inferred rather than recorded. Written language is recent, astonishingly so. For over 95% of our existence as a species, there were no written records at all. Everything we think we know about that vast stretch of time comes from fragments, bones, tools, fire pits, impressions left in mud that hardened long enough to survive. Now imagine how fragile those traces are. how easily erased by glaciers, floods, volcanic eruptions, rising seas, entire coastlines swallowed, plains buried under sand, forests turned to deserts. If a society existed tens of thousands of years ago and was later erased by natural forces, what would remain? Not much, and certainly not a neat archive labelled for modern researchers. This is where the idea of a lost chapter begins to feel less like fantasy and more like a statistical possibility. Not a forgotten global empire with flying machines and crystal towers, but something subtler. A phase of human development that does not align neatly with the timeline we've drawn. A period of experimentation, organisation, or knowledge that rose and fell before history had the tools to remember it. Science does not deny this possibility outright. In fact, it acknowledges something even more unsettling. Our understanding of prehistory is incomplete by necessity. We work with what survives, not with what existed. Absence of evidence is not evidence of absence. It's simply absence. And yet certain discoveries push that idea further than is comfortable. There are stone structures whose precision seems excessive for their age. Sites that suggest large-scale cooperation before agriculture was supposed to make such cooperation possible. Carvings and alignments that appear to encode astronomical knowledge long before formal astronomy. Again and again, researchers find themselves asking the same quiet question. How did they know this? And why then? It's tempting to rush toward dramatic explanations. Lost civilizations, advanced technologies wiped out by disaster, visitors from elsewhere. Those stories are emotionally satisfying because they fill gaps quickly, but they also bypass the more interesting question. What if early humans were simply more capable than we've given them credit for? What if intelligence, organisation and symbolic thinking emerged earlier, flourished briefly, and then were interrupted? Human history is not a straight line. Genetics tells us that. Our species nearly went extinct more than once. Climate records show periods of extreme instability. Ice ages advanced and retreated, reshaping habitable land again and again. In such conditions, progress would not look like a steady climb. It would look like bursts and collapses. Knowledge gained, then lost. Skills refined, then abandoned. Imagine a small population developing advanced stoneworking techniques over generations, only to be scattered by climate shifts. Imagine ritual centres built not as cities, but as gathering points, later buried and forgotten when the people moved on. Imagine stories passed orally for thousands of years, slowly changing, eventually becoming myths that sound symbolic rather than historical. This is where science and storytelling overlap uncomfortably, because myths are often treated as the opposite of data, and yet, myths are memory systems. They encode information in narrative form. Flood stories appear in cultures separated by oceans. Tales of earlier ages, destroyed worlds, or teachers who came before recur again and again, not as proof, but as hints that something older echoes beneath recorded history. Science approaches these ideas cautiously, as it should. But caution does not mean dismissal. In recent decades, new tools have begun reopening questions once thought settled. Advanced dating methods, satellite imaging that reveals buried structures beneath jungles and deserts, genetic analysis that traces migrations with increasing precision. Each new technique peels back another layer, and sometimes what's underneath is not what we expected. Sites once believed to be primitive turn out to be sophisticated. Timelines stretch backward. Assumptions soften. And slowly the possibility grows that the story we learned is not wrong, but abbreviated. What makes this especially intriguing is that science often finds these surprises accidentally. A site uncovered during construction. An artifact miscatalogued for years before someone notices the inconsistency. A reanalysis of old data using new methods. The lost chapter does not announce itself. It emerges reluctantly, piece by piece, as if unsure whether it wants to be read. and perhaps that hesitation is fitting. Because rewriting history is not just an academic exercise, it changes how we see ourselves. If humans organised complex societies earlier than believed, it challenges ideas about progress. If knowledge can be lost on a large scale, it reframes modern confidence. If civilization is fragile, not inevitable, the future feels different. This is not about diminishing science. It is about watching it work honestly. Real science does not cling to comforting narratives. It follows evidence, even when it leads into uncertainty. And uncertainty, while uncomfortable, is also where curiosity thrives. As we move forward from here, we won't be chasing sensational answers. We'll be paying attention to the quiet discrepancies, the places where dates don't align, the artifacts that seem out of place, the human footprints that appear earlier than expected. Each of these is a sentence fragment from a longer story, one we're only beginning to reconstruct. For now, let your thoughts settle into that idea, that history is not finished, that the past is not fully known, that beneath the surface of what we teach and repeat, there may be earlier attempts, earlier experiments, earlier versions of humanity trying to understand the same world we inhabit now. Nothing here requires belief, only patience, only openness, only the willingness to sit with questions that don't resolve immediately. At some point, usually without much ceremony, the timeline starts to wobble, not in a dramatic everything you know is wrong kind of way, but more like a shelf that's been nudged just slightly out of level. At first, you might not notice it at all. The dates still look sensible, the arrows still point forward, the general story still works, and yet, when you pause and look carefully, there are small mismatches, tiny overlaps, events that seem to arrive a little too early, or linger a little too long, as if they missed a memo about when they were supposed to exist. This is where science becomes most honest, and perhaps most interesting. Because timelines, for all their usefulness, are models. They're built from best estimates, surviving evidence, and assumptions that usually hold up well. But they are not sacred. They are revised, stretched, and sometimes quietly redrawn when new information appears. Human history, especially deep prehistory, is stitched together from fragments separated by enormous gaps. Tens of thousands of years can vanish between two datable layers of soil. Entire cultures can rise and fall in the silence between one piece of evidence and the next. When we draw a timeline of early humanity, we're connecting dots that are often very far apart, hoping the line between them is reasonably accurate. Most of the time, it is. But sometimes, a dot appears where no line was expected. Take the accepted outline most people are taught. For hundreds of thousands of years, humans lived as hunter-gatherers. Small groups, mobile lives. Tools gradually improved, but society remained relatively simple. Then, around 12,000 years ago, something changed. Agriculture emerged. Permanent settlements followed. Population grew. Writing, cities, states, and eventually civilization as we recognize it took shape. This sequence makes intuitive sense. Farming allows surplus. Surplus allows specialization. Specialization allows complexity. The problem is that some discoveries do not politely wait their turn. Archaeologists have uncovered evidence of large-scale construction, symbolic art, and organized ritual activity that predates agriculture, not by a small margin, but by several millennia. According to the traditional model, this should not really be possible. Building monumental structures requires planning, cooperation, resource management, and time. All things thought to depend on settled agricultural life, and yet, there they are. One of the most striking examples is Göbekli Tepe, a site in southeastern Turkey that dates back more than 11,000 years. That places it firmly before the advent of farming in the region. The site consists of massive stone pillars, some weighing many tons, arranged in circular enclosures. They are carved with detailed reliefs of animals, abstract symbols, and human-like forms. What makes this unsettling for the timeline is not just the age, but the sophistication. These stones were quarried, transported, carved and erected with remarkable precision, all by people who, according to previous assumptions, were nomadic hunter-gatherers without permanent settlements or agriculture. Even more puzzling, after centuries of use, the site appears to have been deliberately buried. Not abandoned and forgotten, but intentionally filled in, as if closed with purpose. That act alone implies long-term planning and cultural continuity. This discovery did not overthrow the timeline overnight. Instead, it forced a re-evaluation. Perhaps social complexity did not wait for agriculture. Perhaps shared belief systems, ritual gatherings, or symbolic meaning came first and helped drive the development of farming, rather than the other way around. Once that door opens, other anomalies start to feel less isolated. Consider stone tools found in layers far older than expected. In several parts of the world, archaeologists have uncovered evidence of human tool use tens of thousands of years earlier than migration models once allowed. In some cases, tools appear in regions long before humans were thought capable of reaching them. Dating methods are checked, rechecked, debated. Often, the dates hold. In North and South America, for instance, the long-standing idea that humans arrived no earlier than around 13,000 years ago has been steadily eroded. Sites with clear signs of human activity keep pushing that date back. 16,000 years. 20,000. In some controversial cases, even earlier. Each time the response is cautious, as it should be. Extraordinary claims demand strong evidence, but the pattern keeps repeating. The timeline stretches, reluctantly, backward. The same thing happens with art. Cave paintings were once thought to represent a relatively late development in human cognition, a sign that symbolic thinking had finally emerged. Then older and older examples were found, some dating back over 40,000 years. Complex, intentional, expressive works created by people whose lives are otherwise almost invisible to us. These were not crude experiments. They show planning, technique, and aesthetic sense. They imply teaching, shared symbols, and cultural continuity. All things that suggest minds operating in ways not so different from our own. The timeline can accommodate this, but it becomes less linear as it does. Instead of a gradual climb from simple to complex, it starts to look more like a landscape with peaks and valleys. Advances appear early, disappear, reappear elsewhere, or take different forms. Then there are the gaps, periods where evidence thins dramatically, not because nothing happened, but because conditions were unfavourable for preservation. Ice ages scrape landscapes clean. Rising seas drown coastal settlements, which is particularly important because early humans were likely coastal foragers. Some of the most ancient and potentially informative sites may now lie underwater, inaccessible or unexplored. If entire populations lived and died along ancient shorelines, their traces would be among the first to vanish. The timeline we draw would then be missing not just details but entire chapters. Genetics adds another layer of complexity. As genetic analysis has improved, it has revealed that human populations mixed, split, and migrated in ways far more intricate than once believed. We are not the product of a single clean lineage marching forward. We carry traces of multiple archaic human groups. Some interactions happened much earlier than expected. Others happened in places no one predicted. These genetic timelines do not always line up neatly with archaeological ones. Instead, they suggest periods of overlap, coexistence and disappearance that complicate the story of progress. And then there are structures. Stone arrangements, earthworks and megalithic sites scattered across the globe that defy easy categorization. Some are clearly later. Others sit awkwardly in time, their purpose uncertain, their construction methods debated. In some cases, erosion patterns suggest great age. In others, Alignments hint at astronomical knowledge that would require long-term observation of the sky. None of this proves the existence of a lost advanced civilization. But it does suggest sustained, organised activity over long periods, sometimes earlier than expected. Science responds to these findings not with panic but with revision. Timelines are adjusted, models become more flexible, language becomes more careful. Phrases like earliest known replace definitive claims, and this is exactly how science is supposed to work. What makes this moment in history particularly interesting is that we're in the middle of one of these revisions. New tools are revealing things faster than theory can always keep up. Satellite imagery finds buried structures beneath forests and deserts. Improved dating methods refine ages with greater precision. Old collections are re-examined with fresh eyes. Each time, the timeline becomes a little less tidy, but a little more honest. This discomfort often spills into public discussion as confusion or sensationalism. Claims of ancient super-civilizations or forbidden knowledge capture attention because they offer simple answers to complex questions. But the real story is quieter and arguably more fascinating. It is the story of a species that experimented, adapted, and sometimes failed long before written memory. A species whose capabilities emerged earlier than expected, whose progress was not guaranteed, and whose past includes episodes we're only beginning to glimpse. When the timeline doesn't quite add up, it doesn't mean science is broken. It means the picture is incomplete. And incompleteness is not a flaw, it's an invitation to look more carefully at assumptions, to accept that absence of evidence reflects the fragility of the past, not the simplicity of it, to acknowledge that humans have always been more complex than the stories we tell about them. The question becomes less about forcing the past to fit a clean sequence, and more about understanding how messy real history actually is. Development did not happen everywhere at the same pace. Knowledge did not spread evenly. Some ideas appeared early, vanished, and had to be rediscovered later. Long before stone walls rose, before fields were planted in neat rows, before anyone thought to mark a year or name a king, humans were already leaving one of the most intimate records imaginable. Not tools, not monuments, footprints. A footprint is a strange kind of evidence. It is personal without being intentional. It captures a moment rather than an idea. Someone passed through here. They were alive. They were moving. They had weight, balance, direction, and purpose, even if we will never know exactly what that purpose was. And in rare circumstances, those fleeting impressions harden, survive erosion, survive time, and reach us tens of thousands of years later with unsettling clarity. For a long time, footprints were considered curiosities rather than serious data. Interesting, yes, but fragile, difficult to date, and often ambiguous. After all, how do you know who made them, or when, or under what conditions? A stone tool can be shaped, classified, compared. A footprint is just a moment pressed into mud. But moments matter. As dating techniques improved and geological analysis became more precise, certain discoveries refused to stay in the category of curiosities. They demanded attention because they did something quietly disruptive. They placed humans in places, and at times where the established timeline said they should not yet exist. One of the most striking examples comes from what is now the southwestern United States, at a place known as White Sands National Park. Today it's famous for its rolling gypsum dunes, bright, soft, and almost otherworldly. Thousands of years ago it was something very different. A landscape of shallow lakes and wetlands, fed by melting ice from the last ice age. Muddy shorelines, soft sediment, perfect conditions for preserving footprints. In recent years, researchers uncovered a long trail of human footprints there, embedded in ancient lakebed sediments. At first glance, the tracks looked familiar. Bare feet, clear heel-to-toe impressions. The size and shape suggested adults and children moving together. Nothing extraordinary about that, except for one detail that changed everything. their age. Using radiocarbon dating of plant seeds embedded in the same layers as the footprints, scientists arrived at dates between roughly 21 and 23,000 years ago. That places these people in North America during the height of the last ice age, thousands of years earlier than the long-accepted timeline for human arrival on the continent. This wasn't a single isolated print that could be waved away as contamination or misinterpretation. It was a trail, multiple layers, repeated visits over time, children playing or walking alongside adults, people turning, pausing, changing pace. In one case, a set of footprints suggests someone carrying a child, setting them down, then picking them up again. It's hard to argue with that kind of detail. Tools can be transported, stones can be reused. But footprints require bodies, present in that place, at that moment. The implications were immediate and uncomfortable. If humans were present in North America more than 20,000 years ago, then the standard model of migration had to change. The idea that people arrived only after ice sheets retreated enough to allow passage through an inland corridor no longer held up. They were there earlier somehow, navigating harsher climates, adapting to environments we once assumed were uninhabitable. Science did what it always does in these moments. It slowed down. Methods were scrutinized, dates were challenged. Alternative explanations were proposed. Could the seeds have moved? Could the layers have been disturbed? Multiple teams revisited the site, reanalyzed the data and tested different samples. The dates held, and White Sands is not alone. Across the world, footprints have quietly complicated the story of when and where humans lived. In East Africa, the famous footprints at Laetoli are far older, dating back about 3.6 million years. Those were left by early hominins, not modern humans, and they confirmed something revolutionary when discovered. That upright walking, bipedal movement existed long before large brains or advanced tools. The timeline shifted then too, reminding scientists that assumptions about progression often lag behind evidence. While Laetoli sits far deeper in evolutionary time, it established an important precedent. Footprints could rewrite history. What makes more recent footprints especially challenging is that they intersect with questions of civilization, not just biology. They place modern humans, or people indistinguishable from us in anatomy and behaviour, into periods where we expected only sparse populations or none at all. In some locations, footprints appear alongside tracks of extinct animals. Mammoths, giant sloths, animals that disappeared at the end of the Ice Age. In certain cases, human footprints intersect with these tracks, suggesting encounters, perhaps hunting, perhaps avoidance, perhaps curiosity. The exact nature doesn't matter as much as the coexistence. That coexistence matters because it implies ecological knowledge, awareness of dangerous animals, strategies for survival, social coordination. These were not isolated wanderers stumbling blindly into new worlds. They were people navigating complex environments with intention. This challenges an unspoken assumption that early humans were always on the brink of failure, barely surviving. The footprints tell a different story. One of resilience, planning, and adaptability. The presence of children is particularly revealing. Adults might take risks, exploratory journeys, dangerous crossings, but children suggest stability, repeated occupation, a level of safety deemed acceptable for families, not just individuals. This is where the idea of civilization becomes slippery. We often equate civilization with buildings, writing, agriculture, and permanent cities. But those are outcomes, not prerequisites, of complex human behaviour. Social structures, shared knowledge, cooperation, and cultural continuity can exist without stone walls or written records. Footprints don't tell us about governments or gods, but they tell us something just as important. Humans were living full lives, with families and routines, far earlier than we once thought. Other footprint sites add to this picture in quieter ways. In parts of Europe, Tracks suggest human movement in cold environments during periods previously considered marginal. In Australia, evidence of human presence continues to push back arrival dates, supported not just by tools, but by traces of repeated land use. Each discovery alone might seem manageable, a date adjustment here, a migration route tweak there. But together, they create pressure. The timeline stretches not because of speculation, but because people were physically present where the old model said they weren't. And once again, we're confronted with gaps. Footprints preserve moments, not stories. They don't explain how people got there, what technologies they used, or what knowledge they carried. They only confirm presence. But presence is powerful. It forces every other explanation to catch up. How did these people cross vast distances? How did they survive glacial climates? What social structure supported them? What knowledge did they pass down that left no obvious material trace? These questions don't point toward lost advanced technology. They point toward lost context. Much of what humans do does not fossilize well. Clothing made from plant fibers or animal hides, wooden tools, boats, shelters, songs, spoken instructions. None of these survive easily, and yet they are central to survival, especially in challenging environments. If early humans reached distant continents earlier than believed, they almost certainly used technologies that left little trace: simple watercraft, coastal navigation, seasonal movement patterns, all practical, all plausible, all nearly invisible archaeologically. Footprints then become rare snapshots of otherwise hidden behaviour. There is also an emotional reaction to these discoveries that science doesn't always acknowledge openly, but that matters nonetheless. Seeing a footprint that is unmistakably human, thousands of generations old, creates a sense of continuity that tools or bones don't quite capture. Someone stood here. They shifted their weight. They moved forward. They existed, and they existed long before history remembers them. This challenges not only timelines, but narratives of progress. It suggests that the roots of human adaptability run deeper than our monuments. That ingenuity and cooperation are not recent achievements, but ancient traits that allowed us to spread across the planet under conditions far more extreme than most of us will ever face. It also reframes the idea of a lost chapter, not as a golden age erased by catastrophe, but as a long, complex prelude written in materials that rarely survive: mud instead of stone, motion instead of objects. Science is still catching up to this realization. Each new footprint discovery is treated carefully, skeptically, methodically, as it should be. But the pattern is becoming harder to ignore. Humans were present earlier, in more places, living fuller lives than the tidy timeline once allowed. And footprints are only the beginning. Long before anyone carved dates into stone or counted years with symbols, humans were shaping the world with their hands. Tools are often described as extensions of the body, and that description turns out to be more literal than poetic. A tool preserves intention. It shows planning, knowledge of materials, and an understanding that effort now can make survival later a little easier. When archaeologists find tools, they are not just finding objects, they are finding decisions. For a long time, tools have been one of the main anchors of the human timeline. Certain types of tools are associated with certain periods. Crude stone flakes appear first, then more refined hand axes, later blades, needles, composite tools, and eventually metal. This progression makes sense. It matches how learning accumulates. It gives structure to prehistory. The problem arises when a tool shows up too soon. Not a little early, but thousands or even hundreds of thousands of years earlier than the timeline comfortably allows. When that happens, science does not jump to conclusions. It slows down. It asks whether the object really is a tool, whether it could be natural, whether the layer was disturbed, whether the dating is reliable. In most cases, those questions resolve the issue, but in some cases they don't, and those cases accumulate. One of the most well-known examples involves stone tools found in East Africa that predate the genus Homo itself. At sites like Lomekwi, researchers uncovered stone tools dated to about 3.3 million years ago. That is roughly 700,000 years earlier than the oldest previously known tools. These tools were not accidents. They showed deliberate flaking, intentional shaping, and repeated patterns. Whoever made them understood how stone breaks and how to control that process. At the time, the only hominins known to exist were species not previously thought capable of such behaviour. This discovery forced scientists to rethink assumptions about intelligence and capability. Tool use did not suddenly appear alongside bigger brains. It emerged earlier, in simpler forms, and likely evolved gradually across different hominin species. The timeline shifted, but in a way that could be integrated into evolutionary theory. More troubling are tools that appear too early not for biology, but for civilization. In various parts of the world, stone tools have been found in geological layers far older than expected based on migration models. In the Americas, for instance, tools associated with human activity keep appearing earlier than the long dominant model allowed. For decades, the Clovis culture was considered the first human presence in North America, dating back about 13,000 years. Clovis tools are distinctive, carefully shaped spear points, elegant, symmetrical, and clearly the product of skilled craftsmanship. The assumption was that people arrived, developed this technology, and spread rapidly. Then earlier tools appeared. At sites scattered across North and South America, stone implements lacking the distinctive Clovis style were found in older layers. At first, these were dismissed. Maybe they were natural fractures. Maybe the dating was off. But as more sites emerged, patterns began to form. These tools were simpler but not crude. They were functional, effective, designed for cutting, scraping and processing materials, and in some cases they dated back well beyond the accepted arrival window. What makes these discoveries unsettling is not just their age, but their context. Some of these tools are found alongside evidence of repeated occupation, hearths, animal processing areas. In rare cases, footprints. Together they suggest not fleeting presence, but sustained activity. This raises an obvious question. If people were here earlier, what tools did they use, and why do so few remain? The answer may lie in bias, not conspiracy. Stone tools survive well. Wooden tools do not. Bone tools survive only under specific conditions. Fibre tools almost never survive. If early humans relied heavily on organic materials, the archaeological record would drastically underrepresent their technological sophistication. A sharpened wooden spear, for example, is devastatingly effective and leaves almost no trace after a few centuries, let alone tens of thousands of years. Clothing, nets, baskets, boats, shelters, all essential for survival, vanish almost completely. What remains are stones, and even then only some stones. Another complicating factor is reuse. Early humans often reused older tools or materials left behind by previous groups. A tool found in a younger layer might actually be far older than the layer itself. Conversely, a tool buried deep might be disturbed by natural processes and appear older than it is. Sorting this out requires painstaking work. Yet despite these complications, certain tools continue to resist comfortable explanation. In parts of Asia, stone tools appear in contexts suggesting human presence earlier than genetic models predict. In Australia, evidence of tool use stretches back more than 60,000 years, requiring sea crossings that were once thought impossible for people without advanced navigation. Those crossings are not trivial details. They imply planning, boats or rafts, knowledge passed down over generations, an understanding of tides, currents, and seasonal patterns. None of that leaves much of a trace. And then there are tools that seem oddly refined for their supposed age. Grinding stones, for example, have been found in contexts far older than agriculture. Grinding implies processing plant material, possibly grains, possibly tubers. Either way, it suggests dietary strategies more complex than opportunistic foraging. Some sites show evidence of composite tools, stone points attached to wooden shafts using adhesives made from plant resins or bitumen. Making such adhesives requires controlled heating, material knowledge, and experimentation. It is not accidental behaviour. When these tools appear earlier than expected, the response is often to push back the date of that technology's invention. But doing so repeatedly has consequences. It means humans were innovating continuously, adapting technologies long before we credit them for doing so. This undermines the idea that technological progress is tightly linked to settled civilization. Instead, it suggests that mobile groups were perfectly capable of complex problem-solving, experimentation, and teaching. The timeline becomes less about sudden revolutions and more about long periods of quiet refinement. There is also a psychological factor at play. We tend to associate complexity with permanence. Cities feel advanced because they endure. Nomadic life feels simple because it leaves fewer marks. But endurance is not the same as sophistication. A temporary shelter built efficiently and repeatedly may represent more knowledge than a poorly planned permanent structure. Tools reflect this. Many early tools are elegant in their efficiency, minimal material, maximum function, no excess. When tools appear too early, it forces us to reconsider not just when people lived, but how they lived. Did early humans have seasonal gathering points where knowledge was exchanged? Did techniques spread through social networks that left no physical trace? Did entire traditions rise and fall without ever becoming archaeologically visible? Science does not answer these questions with speculation. It answers them with patience, with replication, with cautious language. But the pattern is clear. The deeper we look, the earlier human ingenuity appears. This does not point to a lost high-tech civilization. It points to something more subtle and perhaps more impressive, a long adaptive human story where innovation was constant but preservation was rare. Tools that appear too early are not anomalies to be dismissed. They are signals, indicators that our timeline, while useful, is still incomplete, and tools are only part of the picture. For a long time, the idea of a city came with very specific expectations. Walls, streets, permanent houses, storage facilities, social roles, all of it rooted firmly in agriculture. The logic seems straightforward. You cannot support large, dense populations without farming. You cannot farm effectively without settled land. Therefore, cities must come after agriculture, not before it. That assumption shaped decades of archaeological thinking. When researchers encountered evidence that didn't fit, it was often interpreted through that lens or quietly set aside. But as with footprints and tools, certain sites refused to behave. They did not wait patiently for the moment history said they were allowed to exist. Instead, they appeared early. Too early. What complicates this discussion immediately is language. The word city carries modern baggage, skyscrapers, bureaucracy, governments. None of that applies here. But if we strip the idea back to its essentials, a city is simply a place where large numbers of people gathered repeatedly, organised space intentionally, shared resources, and coordinated their lives over time. No writing required, no kings required, just sustained social complexity. When defined that way, the timeline starts to strain. One of the earliest sites to force a serious rethink was Jericho. Located near a reliable water source, Jericho has been occupied on and off for thousands of years. What startled archaeologists was not just its longevity, but its antiquity. The earliest known settlement layers date back to around 9000 BCE, well before what was once considered the beginning of urban life. Even more surprising was what those early inhabitants built. A substantial stone wall, a massive tower rising several meters high. These were not casual constructions. They required planning, labour coordination, and a shared purpose. For a long time, scholars struggled to explain why such a structure existed at such an early date. Defense was one suggestion. Flood control was another. Symbolic or ritual functions have also been proposed. What matters is not which explanation is correct, but the fact that people living there organised themselves well enough to build something far beyond immediate survival needs. That level of coordination challenges the idea that early settlements were loosely organised camps. It suggests leadership, shared goals, and an understanding of collective effort. Jericho was once treated as an exception, a lucky fluke, but exceptions lose their power when they multiply. Another site that quietly dismantled old assumptions is Çatalhöyük. Located in what is now Turkey, this settlement dates back to around 7,500 BCE and housed thousands of people at its peak. There were no streets in the conventional sense. Instead, houses were packed tightly together, and people moved across rooftops, entering homes through openings in the ceiling. This was not chaotic. It was intentional. The layout reflects shared norms, repeated construction patterns, and long-term continuity. Homes were rebuilt in the same locations over generations. Walls were decorated with paintings. Burials were placed beneath floors, tying family memory directly to living space. What makes Çatalhöyük particularly unsettling for the old timeline is that it appears during a transitional period. Agriculture was present, but not fully dominant. Hunting and gathering still played a major role. This was not a simple farming village. It was a dense, socially complex settlement operating in a hybrid economic system. There is no evidence of centralised authority, no palaces, no obvious ruling class. And yet the community functioned. Order was maintained, space was negotiated, cultural practices were shared across thousands of people. This suggests that social organisation does not require hierarchy in the way we often imagine. Cooperation alone can sustain large populations, at least for a time, and then there are places that push even further back. In recent decades, archaeologists have identified large, permanent or semi-permanent settlements dating earlier than expected in multiple regions. Not always as visually dramatic as later cities, but clearly more than seasonal camps. These sites show repeated construction, long-term occupation, and evidence of social structure. What makes them difficult to classify is that they don't fit neatly into categories. They lack writing, formal architecture, and clear economic specialisation. But they exceed what we would expect from small mobile groups. The uncomfortable possibility is that early humans experimented with collective living long before it became widespread or permanent. Why would that be? One explanation is ritual. Large gatherings may have formed around shared beliefs rather than food production. People could come together seasonally for ceremonies, exchanges, or social bonding. Over time, those gatherings might become more frequent, more structured, and eventually semi-permanent. Another explanation is environmental opportunity. Stable climates and abundant resources could support larger groups without intensive agriculture. Rivers, lakes, and rich ecosystems can sustain dense populations if managed carefully. A third possibility is that agriculture itself may not have been the starting point, but the outcome. Once people began living together in large numbers, the pressure to produce reliable food sources would increase. Farming could emerge as a solution to crowding, not the cause of it. This reverses the traditional story. Instead of farming creating cities, cities may have created farming. Evidence from early settlements supports this idea more than once. In some cases, the earliest layers show little sign of intensive agriculture. Only later do domesticated plants become dominant. This suggests a gradual shift, driven by social needs rather than sudden innovation. Science has been slow to accept this reversal, not because it is implausible, but because it disrupts a deeply ingrained narrative. Progress is often imagined as technological first, social second. But humans are social creatures before they are engineers. Shared meaning, shared space, and shared identity often come before material efficiency. There is also the matter of scale. When people imagine early cities, they picture massive stone ruins, but scale can be deceptive. A settlement does not need monumental architecture to function as a city. It needs continuity, density, and coordination. Many early sites meet those criteria quietly, without dramatic remains. The challenge is preservation. Early buildings were often made of mud brick, wood, and organic materials. These degrade easily. What survives is often just a footprint in the soil, a post hole, a subtle pattern that only becomes visible through careful excavation. Entire settlements may have existed and vanished without leaving clear traces, flooded, eroded, buried, forgotten. Coastal settlements are especially vulnerable. Rising sea levels since the end of the last ice age have submerged vast areas that were once habitable. If early cities formed along ancient coastlines, as many modern cities have, they may now lie underwater, inaccessible and unstudied. Marine archaeology is still in its infancy. What little we have explored suggests that submerged landscapes once supported human activity. As technology improves, more may be revealed, and with it, more pressure on the timeline. Another factor that complicates interpretation is expectation bias. When archaeologists look for cities, they look for things they recognise: streets, walls, central buildings. When early settlements don't match those patterns, they are sometimes described as something else: villages, camps, transitional sites. But function matters more than labels. If thousands of people lived in one place over generations, shared norms, coordinated activities, and maintained continuity, that place functioned as a city, regardless of whether it resembles later examples. Science is beginning to acknowledge this cautiously. Language is shifting. Terms like proto-urban or early complex settlement appear more frequently. These are attempts to expand the conceptual framework without discarding it entirely. The idea of cities before history does not imply a lost global civilization. It implies experimentation, multiple attempts at dense living. Some succeeded for centuries, others collapsed. Knowledge was not always cumulative, sometimes it reset. This perspective aligns with what we know about human vulnerability. Climate shifts, resource depletion, disease, and conflict can undo generations of stability quickly. A city does not need to be destroyed violently to vanish. It only needs to become unsustainable. When that happens, people leave. Structures decay, memory fades, the land reclaims the space. Without writing, the story ends there. What remains is a faint signal in the soil, waiting for someone to notice. As more of these early settlements are uncovered, the story of human history becomes less linear and more textured. Not a single march toward civilization, but many paths tried, abandoned, and sometimes rediscovered. This has implications beyond archaeology. It challenges the idea that modern society is the inevitable result of progress. It suggests that complex living arrangements are fragile achievements, not permanent milestones. It also reframes the lost chapter, not as a hidden empire erased by disaster, but as a long series of social experiments, most of which left little trace. Cities before history were not mistakes. They were learning processes, and learning processes leave echoes. Those echoes appear in later civilizations, in how space is organized, in how communities form, in how ritual and cooperation bind people together before law or writing ever do. Understanding this does not diminish modern achievement. It deepens it. It places us within a much longer continuum of human problem solving, one that began far earlier than our timelines once allowed. Somewhere along the long stretch of human time, people began doing something that, even now, is not entirely practical. They started building things that were far larger, heavier, and more enduring than immediate survival required. Not shelters that could be packed up and moved, not tools that fit in the hand, but massive structures made of stone, placed with care, effort and intention, meant to last far longer than the people who built them. These monuments are among the most persistent disruptions to the tidy version of history. They are visible, measurable, and difficult to dismiss. You can walk around them, touch them, map them, and yet, when you ask the simplest questions about them, how they were built, why they were built when they were, and what knowledge was required, the answers become surprisingly uncertain. At first glance, monuments seem like the most straightforward evidence of civilization. Big structures imply organised societies. Organised societies imply agriculture, hierarchy, and surplus. But once again, the timeline begins to strain when monuments appear earlier than expected, or when their construction methods seem out of proportion to the technologies attributed to their builders. This is not a matter of mystery for mystery's sake. It's a matter of logistics. Stone is heavy. Transporting it requires planning. Shaping it requires skill. Aligning it requires knowledge. Coordinating large numbers of people over long periods requires social organisation. None of that happens accidentally. And yet, some monuments appear in contexts where the supporting framework, at least as we currently understand it, seems incomplete. Perhaps the most famous example is Stonehenge. Its silhouette is instantly recognisable. A ring of massive standing stones, some topped with lintels, arranged with deliberate geometry. For centuries it was treated as an oddity, a curiosity of ancient Britain. Then, as excavation and dating improved, it became something more unsettling. Stonehenge was not built all at once. It evolved over many centuries, beginning around 3000 BCE. What makes it difficult to explain is not just the size of the stones, some weighing up to 25 tons, but their origin. Several of the stones, known as blue stones, were transported from Wales over 150 miles away. Moving stones of that size without metal tools, wheeled vehicles or draft animals is not impossible. Experimental archaeology has shown it can be done, but can and would are different questions. Why would communities invest such effort over generations? What knowledge guided the placement? Why do alignments match solar events like solstices with such precision? Stonehenge does not exist in isolation. It is part of a larger ritual landscape, with nearby earthworks, burial mounds, and avenues aligned with celestial events. This suggests long-term observation of the sky, careful planning, and shared symbolic meaning maintained across centuries. None of this requires lost technology, but it does require continuity of knowledge, teaching, memory, social stability, all of which are difficult to sustain without leaving other traces. Now widen the lens. Across the globe, monuments appear that share certain features despite being separated by vast distances and cultures. Large stone blocks, precise fitting, astronomical alignments, symbolic placement. Each site has its own context, its own history, but the recurring themes invite questions. In Egypt, the pyramids stand as the most iconic monuments of all. The Great Pyramid at Giza, part of the larger complex that includes Giza Plateau, has been studied for centuries. Its age is well established. Its builders are known. Its purpose is broadly understood. And yet, despite this, it continues to generate questions. The precision of its construction is extraordinary. The base is level to within centimetres. The stones fit together with remarkable accuracy. The structure is aligned with true north more precisely than many modern buildings. Mainstream archaeology explains this through skilled labour, simple tools used expertly, and a massive workforce supported by a centralised state. There is no need to invoke lost technology. But even within this framework, the organisational challenge is immense. What often gets overlooked is that the pyramids did not emerge in a vacuum. They appear after a long period of architectural experimentation, which itself implies an even longer tradition of planning, surveying and construction. And then there are monuments that are harder to integrate. In the Andes, at a high altitude near Lake Titicaca, lies the site of Puma Punku. It is part of a larger complex associated with the Tiwanaku culture. The stones here are enormous, some weighing over 100 tons. They're carved with sharp angles, straight lines, and interlocking shapes that resemble modular components. What makes Puma Punku difficult is not just the size of the stones, but their finish. The precision of the cuts has led to exaggerated claims about advanced technology, but precision alone does not imply modern tools. Stone can be shaped with remarkable accuracy using simple methods, given time and skill. The real challenge lies in the absence of clear transitional stages. The culture associated with the site did not leave behind extensive evidence of the incremental development that would normally precede such construction. Much may have been lost, much may remain undiscovered, but as it stands, the site feels like a technological leap within its regional context. Another case comes from the Pacific at Nan Madol. Built on a series of artificial islets, Nan Madol consists of massive basalt columns stacked in a log cabin-like fashion, forming canals, platforms and walls. It is often called the Venice of the Pacific. The logistics here are staggering. Basalt columns weighing several tons were transported over water and stacked with precision. There is no evidence of large populations, metal tools or beasts of burden. The site was built incrementally over centuries, suggesting long-term social organisation and shared purpose. Why build such a place? How was labour mobilised? What belief system justified the effort? These questions are not fully answered. What unites these monuments is not mystery but mismatch. The scale of effort appears out of proportion to what we expect from their social and technological contexts. Not impossible, but surprising. This is where interpretation becomes delicate. There is a temptation to fill gaps with dramatic explanations, lost civilizations, forgotten technologies, external influence. These ideas are compelling because they offer resolution, but they also distract from the more grounded and perhaps more challenging reality. Human beings are capable of extraordinary coordination when motivated by shared meaning. Religion, ritual, identity and cosmology can mobilize labour far more effectively than material need alone. People will carry stones for decades if they believe it matters. They will preserve alignments and traditions across generations if those traditions define who they are. Monuments, then, may represent not technological superiority, but social cohesion. Still, this does not fully resolve the timeline problem. Some monuments appear at times when populations were supposedly small and mobile. Some require knowledge that seems to imply long-term observation. Some appear fully formed, without clear evidence of trial and error phases. And then there is erosion. Many stone monuments show signs of weathering that suggest great age. In some cases, debates arise over whether certain features were shaped by humans or nature. These debates are healthy, but they also highlight how difficult it is to assign dates and functions confidently. The older a monument is, the less context survives. Surrounding settlements erode, organic materials vanish, written explanations never existed. What remains is stone, stubborn and silent. This silence invites speculation, but it also demands humility. Science does not claim to have all the answers here, it claims something more restrained. That monuments reflect behaviours we are still learning how to interpret. That our models of social development may be too narrow. That complexity does not always announce itself with writing or kings. One of the most important shifts in recent years has been the recognition that monument building does not require cities in the traditional sense. It requires coordination, yes, but coordination can arise in many ways. Seasonal gatherings, shared rituals, distributed leadership, oral tradition. The people who built these structures were not primitive. They were not confused. They knew exactly what they were doing within their cultural frameworks. The problem is that we no longer fully understand those frameworks, and that is where the lost chapter becomes tangible. Not a single forgotten empire, but a long stretch of human experimentation with meaning, memory, and permanence. A period where people invested enormous effort into shaping landscapes in ways that mattered to them, even if those reasons are no longer obvious to us. Monuments are not just buildings, they are statements, about time, about continuity, about relationship with the world. When those statements survive but their language is lost, we are left with structure without explanation, and structure without explanation has a way of unsettling modern confidence. As we move from monuments themselves to what they encode, patterns begin to emerge. Alignments with solstices, orientations towards stars, repeated symbols carved into stone across vast regions. These are not decorative accidents. They point toward knowledge systems, ways of understanding the world that were shared, taught, and preserved without writing. And once you begin to notice that knowledge embedded in stone, another question becomes impossible to avoid. What else did early humans know? And how much of that knowledge has quietly slipped out of the record, leaving only faint impressions behind? Stone does not remember in the way people do. It does not recall events, emotions, or stories. But it does preserve patterns, lines carved with intention, shapes repeated with care, alignments fixed against horizons that no longer look the same as they once did. When knowledge is written into stone, it is not meant to be read quickly, it is meant to endure. For much of the modern history, carvings, alignments, and stone markings were treated as decoration or symbolism, interesting but secondary to more practical concerns like tools or dwellings. A spiral here, a notch there, a wall that points somewhere specific. These details were catalogued, sketched, photographed, and then often set aside as cultural flavour rather than data. That attitude has changed slowly, and not without resistance. As researchers began to pay closer attention, a pattern emerged. Many of these markings were not random. They were not merely artistic. They were precise, repeated across sites, tied to environmental cycles, celestial events, and seasonal changes. In other words, they encoded knowledge. The unsettling part was not that ancient people paid attention to the world around them. That much was always obvious. The unsettling part was how much they seemed to know, how consistently they applied that knowledge, and how early some of these systems appeared. Consider orientation. Across continents, stone structures are aligned with the rising or setting of the sun at specific times of year. Solstices, equinoxes, lunar standstills. These alignments are often accurate to within a degree or less. Achieving that kind of precision requires long-term observation. Years, decades, possibly generations. You do not stumble into that accidentally. Take Nabata Playa, located in what is now the Sahara Desert. Today, it is arid and is hospitable. Thousands of years ago, it was a seasonal lake region that supported human populations. There, archaeologists found stone circles and alignments dating back more than 7,000 years. Some of these stones appear to mark the summer solstice. Others align with stars that were visible at the time but have since shifted due to precession, the slow wobble of Earth's axis. The people who placed these stones were not farmers in the later sense. They were pastoralists and foragers, living in a landscape that demanded close attention to seasonal cycles. What they left behind was not a calendar in the modern sense, but a reference system, a way to track time, anticipate environmental changes, and coordinate movement and activity. This kind of knowledge does not require writing, but it does require continuity. Someone has to teach it. Someone has to remember which stone matters and why. Someone has to care enough to maintain the system across generations. That alone challenges assumptions about early societies being loosely organised or short-lived. Now consider repetition. In many regions, similar symbols appear carved into stone across wide areas. Spirals, zigzags, cup marks, lines arranged in specific patterns. Individually, these marks can be ambiguous. Collectively, they suggest shared meaning. In Europe, for example, Neolithic sites feature recurring motifs carved into rock faces and monuments. These carvings are often found near burial sites or ritual spaces. They are placed deliberately, not randomly scattered. Some appear to interact with light and shadow at specific times of year. Light itself becomes part of the message. At certain moments, sunlight illuminates a carving fully, while at other times it disappears into shadow. This requires understanding not just of carving, but of solar movement across seasons. It also implies that these events were anticipated and perhaps observed by groups of people, not just individuals. In the Americas, similar patterns appear in different forms. At Chaco Canyon, massive stone structures built by the ancestral Pueblo peoples show alignments with solar and lunar events. Certain windows and doorways frame the sun or moon at precise moments, creating light patterns that repeat predictably. The famous Sun Dagger site, where shafts of light pass through rock slabs to mark solstices and equinoxes, is one of the clearest examples. It is not decoration. It is a functional display of astronomical knowledge. What makes Chaco Canyon especially relevant is its scale. The site was part of a larger network of settlements connected by straight roads extending for miles across difficult terrain. These roads do not always lead to obvious destinations. Some seem symbolic rather than practical. Symbolic does not mean meaningless. Symbols organize societies. They encode shared understanding. They guide behavior. When symbols are tied to natural cycles, they anchor human activity to the larger world. This is knowledge written in stone, but not as text, as relationship. There is a tendency to underestimate this kind of knowledge because it does not resemble modern science. It is not written in equations or formalized theories, but it is empirical. It is based on observation, pattern recognition, and prediction. Early humans watched the sky because their survival depended on it. Seasons dictated food availability. Animal migrations followed celestial cues. Weather patterns repeated over long cycles. Ignoring these signals would have been costly. Over time, those observations became embedded in culture, in stories, in rituals, and eventually in stone. The difficulty for modern researchers is separating symbolism from function. A carving might represent a deity, or it might represent a star, or it might represent both simultaneously. Ancient worldviews did not draw sharp boundaries between practical and spiritual knowledge. That does not make the knowledge less precise. It makes it harder for us to decode. Another complicating factor is erosion of context. Stone survives. Wood does not. Textiles do not. Paint fades. The stone markings we see today were once part of richer environments filled with colour, sound, and movement. What remains is a skeleton of meaning. Imagine trying to understand modern science from a few concrete foundations and metal bolts, with no diagrams, no books, no spoken explanations. That is the position we are often in with ancient stone knowledge. Despite this, certain patterns are too consistent to ignore. Across the world, early monuments and carving show concern with cardinal directions: north, south, east, west. These directions are marked deliberately. Alignments recur. This suggests systematic surveying, even if conducted with simple tools like shadows, sightlines, and repeated observation. In some cases, stone placements correspond to long-term astronomical cycles that take decades to observe fully. Lunar standstill cycles, for example, repeat every 18.6 years. Tracking them requires sustained attention over a long period, likely longer than a single individual's active working life. This implies institutional memory, knowledge preserved beyond individual lifespans. How was that achieved without writing? Through practice, through repetition, through embedding knowledge into physical spaces that forced engagement. If a ritual site aligns with a celestial event, the event reinforces the knowledge every time it occurs. The stone teaches the observer. This is an elegant solution, one that requires no paper, no ink, no storage, only participation. It also suggests that early humans were capable of abstract thought, long-term planning, and conceptual models of the world that extended far beyond immediate needs. When such systems vanish, they leave behind stone without explanation. And here is where the idea of forgotten knowledge becomes uncomfortable. It is not that ancient people knew things modern science does not. It is that they knew things in ways modern science does not prioritize. They integrated observation, environment, and meaning into cohesive systems that did not survive cultural collapse well. When populations moved, declined, or reorganized, these systems could disappear entirely. A new group might inherit the stones without inheriting the knowledge. The carvings become mysterious. The alignments become accidents. Meaning erodes. This has likely happened many times. In the Andes, for instance, sites like Machu Picchu show precise stonework and astronomical alignment. The Inca were relatively recent, and even their knowledge was partly lost after conquest. Yet their stone structures still interact with sunlight in deliberate ways, marking solstices and seasonal changes. Now imagine similar knowledge systems from 10,000 years earlier, passed orally, embedded physically, and then interrupted by climate change or migration. What would remain? Stones, patterns, questions. Science is careful not to romanticize this. There is no evidence of lost advanced physics or secret technologies, but there is strong evidence of systematic observation and environmental intelligence that rivals later developments in its own context. This challenges the assumption that scientific thinking is a recent invention. What is recent is formalization, writing, abstraction divorced from immediate experience. Early knowledge was applied, not theoretical. It lived in practice. That makes it fragile. When practices stop, knowledge stops. When people leave a place, the stones remain, but the meaning goes with them. This reframes the lost chapter again, not as a single forgotten breakthrough, but as countless local knowledge systems, some lasting millennia, others brief, all vulnerable to disruption. As researchers revisit old sites with this perspective, they begin to ask different questions. Not, what does this symbol represent, but what does it do? Not why did they believe this, but what behaviour did this support? Those questions are yielding new insights, but also new uncertainties, because the more we recognise knowledge written in stone, the more we realise how much has been erased, how many systems we will never fully reconstruct, how many observations were made, refined, and then lost. And that realisation leads naturally to a broader concern. If knowledge can be embedded so deeply in landscape and ritual, and then vanish almost completely, what happens when the environment itself changes catastrophically? What happens when floods, droughts, or ice erase not just settlements, but the conditions that made that knowledge meaningful? Human history often gets told as a gradual unfolding. One innovation leads to another. One generation builds on the last. Knowledge accumulates, technologies refine, societies grow more complex. It's a comforting story because it mirrors how we like to think about progress in our own lives. Small improvements, steady forward motion, lessons learned and retained. The Earth does not operate that way. From a geological perspective, stability is the exception, not the rule. Climate shifts abruptly. Ice sheets advance and retreat. Sea levels rise and fall by tens of meters. Volcanic eruptions darken skies for years. Asteroid impacts rewrite ecosystems in an instant. These events are not rare in deep time. They are normal. When human history is placed within that context, the idea of continuous, uninterrupted progress begins to look fragile. For most of our existence, humans lived at the mercy of environmental forces far larger than themselves. We adapted, migrated, regrouped, and adapted again, sometimes successfully, sometimes not. And when adaptation failed, entire populations could disappear, taking their knowledge with them. This is the part of the story that tends to get compressed or softened. We talk about ice ages as slow, glacial processes. We talk about climate change as trends measured in averages. But many past events were abrupt on a human timescale, sudden enough to feel like the world breaking. One of the clearest examples comes from the end of the last ice age, a period that was anything but smooth. As glaciers melted, massive amounts of fresh water poured into oceans and seas, disrupting global circulation patterns. Temperatures rose overall, but not steadily. Instead, they lurched. In some regions, warming suddenly reversed. Within a few decades, temperatures dropped sharply. Ecosystems that had begun to recover were thrown back into cold, dry conditions. Large animals vanished. Vegetation shifted rapidly. Human groups that had adapted to one environment found themselves facing another almost overnight. For people living close to the edge of survival, these changes were devastating. Food sources disappeared. Migration routes closed. Familiar landscapes transformed. Coastal areas flooded as sea levels rose, drowning low-lying settlements that may have existed for generations. Rivers changed course. Lakes vanished or expanded unpredictably. These were not inconveniences, they were existential threats. When modern researchers reconstruct these events, they often focus on environmental data. Ice cores, sediment layers, pollen samples. These tell us what happened to the planet. What they cannot tell us directly is what happened to human societies caught in the middle, but we can infer. If a group relied on seasonal resources that suddenly vanished, they would have been forced to move or perish. If migration routes were blocked by ice or desertification, populations could become isolated and collapse. If sea levels rose rapidly, coastal knowledge, fishing techniques, and navigation routes would disappear along with the people who used them. This matters because many early human populations likely favoured coastlines. Coastal environments offer rich, stable food sources: shellfish, fish, marine mammals, sea plants. These resources can support dense populations without agriculture. They also leave relatively poor archaeological traces once submerged. When sea levels rose at the end of the Ice Age, vast stretches of coastline were lost. Entire ways of life may have vanished with them, leaving little behind but silence. The loss was not just of people, but of accumulated knowledge. Navigation techniques, seasonal calendars, local ecological understanding, social networks that transmitted skills and stories. All of this depends on continuity. Break that continuity, and knowledge resets. This is not speculative. We see it in more recent history. When societies experience catastrophic collapse, knowledge erodes quickly. Skills that require practice vanish within a generation. Infrastructure decays. Oral traditions fragment. Written records burn or rot. Even today, with digital storage and global communication, disasters can erase information permanently. Now imagine societies without writing, without durable materials, without redundancy. Imagine that happening repeatedly over tens of thousands of years. The result would not be a smooth curve of progress. It would be a jagged line, advances followed by losses, innovations rediscovered rather than inherited, regions advancing independently, then collapsing independently. This perspective changes how we interpret archaeological gaps. A gap does not necessarily mean inactivity, it may mean erasure. Consider a hypothetical coastal society that developed sophisticated fishing techniques, seasonal gathering sites, and symbolic traditions tied to the ocean. If rising seas destroyed those settlements and scattered survivors inland, much of that knowledge would become irrelevant or unusable. Inland environments demand different skills. Over time, old practices would be forgotten. If archaeologists thousands of years later excavated inland sites, they might find simple tools and assume simplicity. The coastal chapter would be gone. Multiply this scenario across continents and millennia, and the idea of a lost chapter becomes not only plausible, but likely. Catastrophes also affect social structures. Large, complex communities are vulnerable. They require coordination, trust, and shared purpose. Disruption strains those bonds. When resources become scarce, cooperation can fracture, groups split, leadership structures collapse, cultural continuity breaks. Smaller, more flexible groups may survive better in some conditions, but they cannot preserve the same breadth of knowledge. Specialization declines, skills become generalized, efficiency replaces complexity. This is not regression in a moral sense, it is adaptation under constraint. The archaeological record reflects this. Periods of apparent simplicity often follow periods of greater complexity. For a long time, these patterns were interpreted as gradual development. Now they increasingly look like cycles. There is also the psychological dimension of catastrophe. Traumatic events reshape how societies think about the world. Flood myths, fire myths, stories of lost ages and punished civilizations appear in cultures separated by geography and time. While these stories are not historical records in the modern sense, they may encode collective memory of disruption. Memory does not preserve dates or mechanisms, it preserves impact. A sudden flood that destroys a homeland becomes a story of the world ending. A long drought becomes a story of divine withdrawal. Over generations, details blur, but the core remains. Something was lost. Something changed irreversibly. Science does not treat myths as evidence of specific events, but it does recognize that human memory responds to catastrophe in predictable ways. Stories become containers for loss. When similar stories appear repeatedly across cultures, it raises a cautious question. How many times did human societies experience resets severe enough to imprint themselves on collective memory? Genetics offers another clue. Human genetic diversity shows signs of bottlenecks, periods when populations shrank dramatically. These bottlenecks often coincide with climatic upheavals. When populations collapse, diversity is lost. Entire lineages disappear. With them go cultural traditions. This matters because culture evolves faster than genes. A genetic bottleneck might preserve biological continuity, but cultural continuity can be severed completely. A small surviving group may retain little of the knowledge held by the larger population that preceded it. From the outside, it looks like a new beginning. From the inside, it is survival after loss. This helps explain why certain technologies or practices appear, vanish, and then reappear thousands of years later. It is not necessarily because they were forgotten due to ignorance. They may have been lost due to catastrophe. Stone construction techniques, astronomical knowledge, long-distance trade routes, all require stability. Interrupt that stability repeatedly, and progress becomes episodic. This does not mean humanity was constantly on the brink of extinction. It means that local collapses were common. Some regions thrived while others struggled. Knowledge flowed unevenly. What survived depended on geography, climate, and chance. The comforting idea that civilization steadily climbed out of chaos ignores this reality. It also ignores resilience. Despite repeated resets, humans adapted again and again. They relearned, they reinvented, they rebuilt social systems under new conditions. Sometimes those systems resembled earlier ones. Sometimes they were entirely different. This suggests that human capability was not the limiting factor. Continuity was. When continuity holds, knowledge accumulates. When it breaks, knowledge fragments. Understanding this reframes the lost chapter yet again, not as a single, erased golden age, but as a series of interrupted stories, each region writing its own version. Some chapters preserved, others torn out by floods, ice, fire, or time. Science is only beginning to integrate this perspective fully. It requires collaboration between archaeology, climatology, genetics, and anthropology. It requires accepting uncertainty. It requires resisting the urge to force a clean narrative where none exists. But it also opens new avenues of understanding. If catastrophes reset humanity repeatedly, then traces of earlier complexity may survive only in indirect ways, in myths, in stone alignments that outlast their creators, in inexplicable gaps in the record. And it suggests that what we see as the dawn of civilization may not be the first dawn, but the most recent one to survive long enough to be remembered. Long before anyone carved calendars into stone or measured years with numbers, humans told stories. They told them around fires, along journeys, during rituals, and in the quiet moments before sleep. Stories were not entertainment in the modern sense. They were memory systems, ways of preserving what mattered when nothing else could last. This is why myths are such an uncomfortable category for science. They are not data in the strict sense. They cannot be dated precisely. They shift over time. They absorb symbolism, exaggeration, and metaphor. And yet they persist, across cultures that never met, across continents separated by oceans, across thousands of years of migration, collapse, and reinvention. When the same types of stories appear again and again, the question becomes difficult to ignore. Are these just coincidences of the human imagination, or are they fragments of something remembered imperfectly? One of the most widespread examples is the flood story. Nearly every major culture has one. A great deluge, rising waters, a world destroyed or cleansed. A small group survives, often warned in advance, often guided by some form of knowledge or foresight. After the waters recede, humanity begins again. The version most familiar in the modern West appears in the Epic of Gilgamesh, written on clay tablets more than 4,000 years ago. In it, the hero Utnapishtim is warned of an impending flood, builds a vessel, saves animals and people, and survives a catastrophe sent by the gods. The similarities to later flood narratives are unmistakable. But the Gilgamesh story was not the first. It was already ancient when it was written down. Flood myths appear in ancient India, China, indigenous Australia, the Americas, Africa, and Europe. The details differ, but the structure is strikingly consistent. Water overwhelms the land. Society collapses. Survival depends on foresight, mobility, or retreat to high ground. The world afterward is changed. Science does not treat these stories as literal records of a single global flood. There is no evidence for that. But science does acknowledge something else. At the end of the last ice age, sea levels rose dramatically. In some regions, coastlines moved inland by tens or even hundreds of kilometres. Low-lying plains vanished beneath the ocean. For people living along those coasts, this would have felt like the world ending. Settlements drowned. Familiar landmarks disappeared. Migration became unavoidable. Generations later, the memory of those events would survive not as maps or measurements, but as stories. Stories shaped by emotion rather than precision. Over time, separate flood events in different regions could converge into similar narrative forms, not because they describe the same event, but because humans respond to catastrophe in similar ways. This is where myth starts to look less like fantasy and more like distorted memory. Another recurring theme is the idea of an earlier age, often described as greater, purer, or more ordered than the present. A time when humans lived closer to the gods, possessed greater knowledge, or followed a different set of rules. In ancient Greece, this appears as the age of gold, silver, bronze, and iron. Each age represents a decline from the previous one. In Mesoamerican traditions, worlds are created and destroyed repeatedly, each with its own humanity. In Hindu cosmology, vast cycles of creation and destruction unfold over immense spans of time. These stories are not histories in the modern sense. They are frameworks, ways of understanding impermanence. But they also raise a subtle question. Why is loss such a central theme? Why do so many cultures imagine the past as fuller, richer, or more complete than the present? One explanation is psychological. Humans tend to idealize the past, especially when facing uncertainty. Another is moral. Myths often use decline to explain suffering or enforce social values. But there may be a third layer. If human societies experienced repeated collapses, periods when complexity was lost and later rebuilt, the idea of a better before would not be purely symbolic, it would be experiential. Memory, even fragmented, would carry a sense that something valuable was gone. Consider also the recurring motif of teachers or bringers of knowledge. In many myths, knowledge does not emerge gradually from within society. It arrives, often from figures described as outsiders, survivors, or beings connected to the sky or sea. These figures teach agriculture, astronomy, law, or craft, then disappear. In Mesoamerica, Quetzalcoatl is a civilizing figure associated with knowledge and renewal. In the Andes, Viracocha emerges after a great flood to reorganize the world. In ancient Egypt, Thoth is associated with writing, measurement, and cosmic order. It is tempting to interpret these figures as gods or allegories, and they are, but they may also represent something more grounded. Survivors of earlier disruptions, groups who carried fragments of knowledge into new regions, individuals whose skills were rare enough to feel supernatural. When knowledge is scarce, expertise looks like magic. If a small group preserved astronomical or agricultural understanding after a collapse, their influence on a recovering population would be profound. Over generations, memory of their origins would blur. Stories would replace biographies. Symbolism would replace circumstance. The teacher becomes divine. Another uncomfortable similarity across myths is the emphasis on cycles rather than linear progress. Many traditions describe time as repeating. Worlds are born, flourish, decline, and are destroyed. Humanity is renewed again and again. This contrasts sharply with the modern idea of history as a straight line, but it aligns remarkably well with what we see in the archaeological and environmental record. Stability interrupted by collapse, progress followed by loss, recovery followed by change. Myth encodes that pattern intuitively, not analytically. There are also myths that seem to preserve technical details in strange ways. Some indigenous Australian stories, for example, describe coastlines that no longer exist, passed down orally for thousands of years. These stories align with geological evidence of ancient shorelines submerged by rising seas. The storytellers did not know the mechanisms, they remembered the outcome. In parts of the Pacific, oral traditions recount islands sinking, lands breaking apart, and migrations triggered by environmental change. Archaeology supports these movements, genetics supports them. The stories provide the human perspective. This does not mean myths are accurate records. They are compressed, altered, symbolized. But compression is what memory does under pressure. Another recurring motif is fire from the sky. Stories of stars falling, gods throwing fire, skies burning, or worlds ending in flame appear across cultures. For a long time, these were treated purely as metaphors or moral warnings. Recently, science has begun to reconsider them cautiously. We now know that meteor impacts and airbursts have occurred within human history, not civilization-ending events, but large enough to devastate regions. We know that volcanic eruptions can darken skies, poison air, and alter climate for years. For people without scientific frameworks, these events would be terrifying and incomprehensible. They would be remembered as divine anger, cosmic battles, or the end of an age. Again, myth does not preserve mechanism, it preserves meaning. One of the most important things to understand about oral tradition is that it is selective. It does not aim to preserve everything. It preserves what matters for survival, identity, and warning. Flood stories warn about water. Fire stories warn about the sky. Collapse stories warn about impermanence. From this perspective, myth becomes less about belief and more about transmission. Science struggles with this because it prefers precision, dates, causes, measurable variables. Myth offers none of these reliably, but that does not make it useless, it makes it different. When multiple myths converge on similar themes, they suggest shared human experiences rather than shared imagination. Humans everywhere face environmental forces. They respond emotionally and socially in similar ways. They remember what threatens them most. The uncomfortable part is this. Some myths sound less like abstract lessons and more like echoes. Echoes of floods that erased coastlines, of fires that wiped out regions, of collapses that reset societies. of knowledge lost and partially recovered. This does not mean myths prove the existence of a lost global civilization. That idea oversimplifies and sensationalizes what is far more complex. What myths may point to is fragmentation. Many local histories, many resets, many beginnings. Science does not dismiss this outright. Anthropologists and archaeologists increasingly treat oral traditions as complementary evidence, not as confirmation, but as context, as clues about what to look for and where. In some cases, myths have guided archaeological discovery. Locations described in stories have led to submerged sites. Seasonal rituals have aligned with astronomical features later confirmed scientifically. This does not mean every myth hides a literal truth, but it does mean memory can survive in unexpected forms. When written records are absent or destroyed, stories become archives. They are messy archives, biased, emotional, but resilient. And resilience matters. If humanity experienced repeated resets, then myths may be one of the few threads connecting us to earlier worlds. Not intact threads, but frayed ones. Enough to hint that what we call the beginning may not have been the first attempt. This realization does not undermine science. It deepens it. Science seeks patterns. Myth preserves patterns of experience. When both point in similar directions, cautiously, tentatively, it becomes worth paying attention. As we move forward, the question shifts again. If memory survives collapse through stories, what does not survive at all? What disappears so completely that we do not even remember forgetting it? Between what we can date and what we can describe, there are long stretches where almost nothing speaks back to us. No monuments, no carvings, no stories clearly tied to place, just layers of ice, ash, sediment, and silence. These are the intervals that rarely make it into popular history because they feel empty, but they may be the most important parts of all. History often focuses on presence, who lived where, what they built, what they left behind. The silent gaps force us to confront absence instead. Periods where humans were certainly alive somewhere on Earth, but where their traces were erased so thoroughly that we struggle even to imagine what was lost. These gaps tend to appear between extremes, between ice and fire, between glaciations and warming, between floods and droughts, between stability and catastrophe. From a human perspective, they feel like nothing happened. From a planetary perspective, everything was happening at once. Take ice ages, for example. They're often described as long, slow freezes. In reality, they were dynamic systems marked by rapid fluctuations. Glaciers advanced and retreated. Meltwater flooded plains. Wind patterns shifted. Entire ecosystems migrated hundreds of kilometers in response to temperature changes that, in some cases, occurred within a human lifetime. For people living through these transitions, survival required constant adjustment. Camps could not remain permanent. Migration routes had to change. Knowledge tied to specific landscapes became obsolete when those landscapes vanished beneath ice or water. Now consider what that means for preservation. Ice is brutal to evidence. As glaciers move, they grind rock to powder. They scrape surfaces clean. They destroy structures, crush tools, and scatter bones. When the ice retreats, it leaves behind landscapes that look ancient and untouched, even if people once lived there for thousands of years. If early humans occupied regions later covered by ice sheets, their presence would be almost completely erased, not hidden, destroyed. The same is true of fire, though in a different way. Volcanic eruptions can bury entire regions under meters of ash. Forests burn. Organic material vanishes. Even stone structures can be cracked, buried, or destabilized. Ash layers can preserve moments, like Pompeii, but more often they sterilize landscapes so completely that life must start again from scratch. Between ice and fire there are oceans, As the last ice age ended, sea levels rose by more than 120 metres. This did not happen overnight, but it was fast enough to overwhelm human adaptation in many coastal areas. Low-lying plains disappeared, river deltas flooded, islands shrank or vanished entirely. These were not marginal zones. Coastlines are among the richest environments on Earth. They support fishing, gathering, trade and travel. Early humans almost certainly favoured them, and yet most of those early coastlines are now underwater. This creates a profound bias in the archaeological record. Inland sites survive disproportionately well. Coastal societies, no matter how complex, are underrepresented or missing entirely. Their tools, shelters and ritual spaces lie beneath oceans, often inaccessible and unexplored. What we see then is not a full picture of early humanity. It is a distorted cross-section shaped by geology. The silent gaps are not empty because nothing happened. They are empty because preservation failed. This becomes especially important when we consider timing. Some of the most puzzling jumps in human history occur immediately after major environmental transitions, periods where populations seem to reappear suddenly with new technologies, social structures, or knowledge, as if emerging from nowhere. One interpretation is rapid innovation, another is migration, a third, quieter possibility is continuity hidden by erasure. If a population survived a catastrophic event by retreating to refuges, higher ground or more stable regions, their knowledge would survive with them. When conditions improved, they could expand again. To later observers, it would look like a sudden appearance. The silent gap masks the transition. Genetic evidence supports this idea in subtle ways. Certain lineages show signs of contraction followed by expansion. Populations bottleneck, then spread. The archaeological record often captures the spread, not the contraction. That contraction phase is where silence lives. Consider also deserts. Deserts are not static. Regions that are arid today were once fertile. The Sahara, now one of the harshest environments on Earth, was green and wet multiple times in the past. Lakes dotted the landscape, rivers flowed, human populations thrived. Then the climate shifted, rain patterns changed, vegetation died, lakes dried up, people migrated. Deserts preserve some things well, but they also erase context. Wind erodes surfaces, sand buries and reburies sites, organic material disappears, what remains are fragments, isolated and difficult to interpret. The result is another gap. Add to this earthquakes, landslides, river course changes and soil acidity, and the cumulative effect becomes overwhelming. The Earth is not a neutral archive. It is an active editor. Science works within these constraints. It extrapolates carefully. It uses multiple lines of evidence, but it cannot recover what no longer exists. This is where the lost chapter becomes more than a metaphor. It becomes a recognition of limits. We are reconstructing history from what survived, not from what was most important. That distinction matters. The silent gaps likely correspond to periods of intense human experience. Migration, adaptation, loss, reinvention. These are not trivial moments. They shape culture deeply, but they leave few durable traces. Oral traditions may preserve echoes, myths may carry fragments, but the material record goes quiet. This silence has consequences for interpretation. When we see a new culture appear after a gap, we often describe it as an origin, the beginning of farming, the rise of a new people, the dawn of a civilization. In reality, it may be a reconfiguration, a continuation under new conditions. The gap hides the bridge. This also explains why some technologies appear suddenly and fully formed. They may not be new, they may be reintroduced. Stoneworking techniques, architectural styles, agricultural practices, and astronomical knowledge could survive collapses in reduced form, carried by small groups, then expand when conditions allow. From our perspective, they seem to emerge abruptly. From theirs, they were never entirely lost. The silent gaps also caution against overconfidence. When science draws timelines, it often connects distant points with straight lines. This is necessary for understanding, but it risks oversimplification. The reality between those points may be turbulent, discontinuous, and invisible. Acknowledging that does not weaken science. It strengthens it by making assumptions explicit. There is another aspect to silence that is harder to quantify. Human suffering does not fossilize well. Periods of famine, displacement, and collapse leave little behind compared to periods of abundance and construction. People struggling to survive do not build monuments. They dismantle them. They reuse materials. They move lightly. Their lives matter no less, but their traces fade faster. This creates an ethical dimension to the lost chapter. History favours the stable and the successful. It forgets the disrupted and the displaced. Entire generations may vanish from the record simply because they lived through the wrong kind of time. Recognising silent gaps is a way of restoring balance, of acknowledging that absence is itself meaningful. Between ice and fire, humanity did not pause. It endured. And endurance often looks like simplicity when viewed from afar. This brings us back to the core discomfort. The idea that civilization might not be a single, uninterrupted ascent, but a series of recoveries. If that is true, then what we call prehistory may include multiple phases of organisation, knowledge, and complexity that rose and fell without leaving clear markers. Not lost because they were insignificant, but because the Earth erased them. As research pushes into underwater archaeology, high-resolution climate modelling, and ancient DNA analysis, some of these silent gaps may begin to speak faintly. Coastlines will be mapped, submerged landscapes explored, migration patterns refined, but much will remain unknowable, and that is not a failure, it is a boundary. The silent gaps remind us that human history is inseparable from planetary history, that culture exists within climate, that memory depends on stability, that progress is conditional. They also prepare us for the next realization, because when silence ends, it does not always end gently. Sometimes it ends with artifacts that should not exist, objects that appear isolated, out of context, and difficult to explain within the known flow of history. Items that feel like messages washed ashore after a long destructive storm, and those items force science to ask a final kind of uncomfortable question. Not about memory or catastrophe, but about presence. Who was here when no one was supposed to be at all? Maps are strange objects. They pretend to be practical, but they always reveal more than they intend. A map is not just a record of where things are. It is a record of what someone thought mattered, what they believed could be known, and what they assumed about the world beyond their immediate reach. Every map carries the fingerprints of its time. That is why certain ancient maps are so unsettling. Not because they are accurate in a modern sense, but because they appear to know things they should not. Coastlines drawn with confidence before those coasts were supposedly explored. Landforms hinted at beneath ice. Proportions that seem wrong for guesswork, yet too consistent to be dismissed as imagination. For most of history, maps were understood as symbolic. Medieval maps placed Jerusalem at the centre of the world. Dragons filled unknown seas. Paradise sat somewhere conveniently off to the edge. Accuracy was not the point, meaning was. But some maps do not behave that way. They are not decorative. They are not theological diagrams. They are technical documents, concerned with coastlines, distances, angles, and orientation, and they appear too early. One of the most discussed examples is the Piri Reis map, drawn by an Ottoman admiral and cartographer in the early 16th century. On its own, the map is not extraordinary. It depicts parts of Europe, Africa, and South America, roughly consistent with what was known at the time. What raises eyebrows is the southern portion. The coastline shown bears a resemblance, not perfect but suggestive, to the coast of Antarctica. This would be unremarkable if Antarctica had been discovered. It had not. Officially, it would remain unknown to Europeans for another 3 centuries. Defenders of conventional explanations argue that the map simply extends South America too far south, distorted by projection errors. That explanation is reasonable, but it does not address everything. The map's annotations, written by Piri himself, state that he compiled it from much older sources, some from Arabic maps, some from Portuguese charts, and some, intriguingly, from maps from the time of Alexander. Whether that claim is rhetorical, misunderstood, or literal is impossible to know, but it opens an uncomfortable possibility. That cartographic knowledge circulated, was copied, fragmented and reassembled over long periods, losing context but retaining structure. The Piri map is not alone. Another case often cited is the Orontius Phineus map. This map depicts a southern continent labelled Terra Australis, complete with mountain ranges, rivers and coastlines. Again, Antarctica was unknown. Yet the shape bears similarities to the continent beneath its ice cover, particularly in the placement of major features. Skeptics point out that Terra Australis was a theoretical landmass long believed necessary to balance the continents of the Northern Hemisphere. Cartographers often drew it imaginatively. That is true, but imagination usually lacks consistency. Phineus's map shows internal detail, not just a vague outline. Then there is the issue of ice. Antarctica has been covered by ice for millions of years. No human civilization could have mapped its coastline directly in an ice-free state. This fact is often used to dismiss any suggestion that ancient maps depict Antarctica accurately. But the question is not whether someone stood on an ice-free Antarctic shore with surveying tools. The question is how certain shapes and proportions ended up on maps centuries before exploration. One possibility is coincidence combined with selective interpretation. Humans are excellent at seeing patterns where none exist. When a coastline roughly matches another, we connect them mentally and ignore mismatches. Another possibility is projection distortion. Flattening a sphere onto parchment introduces errors that can make one region resemble another. These explanations account for some similarities but not all, which is why the maps remain controversial, not conclusive. The more interesting angle is not Antarctica itself, but the transmission of knowledge. Maps do not have to be correct to be informative, they only need to preserve relationships. If ancient mariners mapped coastlines they encountered, even partially, that information could be passed along, copied, merged, and altered over centuries. A map compiled in the 1500s might include fragments of knowledge accumulated over 1,000 years or more, without the compiler understanding their origin. This is not speculation. We know this happened. Medieval scholars copied Roman texts. Roman scholars copied Greek ones. Errors accumulated. Context vanished. But the core information persisted. Cartography works the same way. Early Portolan charts, for example, show remarkable accuracy along coastlines of the Mediterranean long before modern navigation tools. These charts were built from accumulated sailor experience, not from theoretical models. Knowledge passed hand to hand, port to port. If similar practices existed earlier, their products could survive in altered form. Another ancient map that unsettles historians is the Zeno map, which depicts islands in the North Atlantic that do not appear on modern maps. Some of these islands may be mythical. Others may correspond to landforms that existed during periods of lower sea level, now submerged. Again, nothing definitive, but enough to raise questions. Then there is the issue of longitude. Accurately determining longitude requires precise timekeeping, something generally believed to be impossible before the invention of reliable marine chronometers in the 18th century. Yet some early maps show east-west positioning that appears surprisingly accurate. The usual explanation is accumulated dead reckoning. Sailors estimated distances by speed and time, corrected over generations. This works to a degree, but it is prone to compounding error. The fact that some coastlines appear consistently proportioned suggests either exceptional skill or inherited reference frameworks. This does not mean ancient people had hidden technology. It means they may have had more experience navigating long distances than we assume, which brings us back to the lost chapter. If early humans favoured coastlines, travelled by water, and exchanged knowledge across wide regions, their navigational understanding could have been substantial. Boats leave little trace, ports erode, coastlines drown. But maps can survive, copied long after the places they depict are gone. There is also the question of what is missing from maps. Some ancient maps omit regions that should have been familiar if the cartographer relied on contemporary exploration. Others include features no one claims to have seen at the time. This asymmetry suggests compilation rather than direct observation. Compilation implies inheritance. Another intriguing example is the Tabula Rogeriana, created by the geographer Al-Idrisi for the Norman king Roger III of Sicily. This map was based on extensive travel accounts and earlier sources. It remained one of the most accurate world maps for centuries. What stands out is its orientation and emphasis. The map is oriented with south at the top, a reminder that conventions change. More importantly, it integrates knowledge from Africa, Asia and Europe seamlessly, suggesting robust information networks. Such networks do not appear overnight. They imply generations of travel, trade and communication. Now imagine similar networks existing earlier, perhaps episodically, perhaps locally, and then collapsing. Their maps would not survive intact, but fragments might, reappearing centuries later in unexpected places. This is not romantic speculation. It is how information behaves when systems fail. Knowledge degrades gracefully. It does not vanish instantly. It breaks into pieces. Ancient maps may represent those pieces. Science remains cautious here, and rightly so. Many claims about impossible maps are exaggerated. Some rely on poor reproductions or selective readings. Others ignore alternative explanations. But science also acknowledges uncertainty. The origin of certain cartographic details remains unresolved. The confidence with which some coastlines are drawn exceeds what we would expect from guesswork alone. This stated reliance on older sources cannot be dismissed entirely. The key point is not that ancient maps prove advanced lost civilizations. They do not. The key point is that they hint at continuity of geographic knowledge that outlasted specific cultures, knowledge that moved independently of political power, knowledge that survived collapse in fragments. Maps are especially vulnerable to this because they are useful. A broken story may be forgotten. A broken map can still guide you somewhere. If humanity experienced repeated resets, as evidence increasingly suggests, then navigational knowledge would be among the most valuable things to preserve. How to find land, how to follow coasts, how to anticipate currents and winds. Such knowledge would spread, mutate, and persist. By the time it reaches a Renaissance cartographer, it may look mysterious, out of place, or anachronistic. Not because it is impossible, but because its context is gone. This reframes the discomfort. Ancient maps that should not exist are not proof of forbidden knowledge. They are reminders of how fragile context is, how easily we lose the story behind the data. When we encounter a map that seems to know too much, the honest response is not to leap to conclusions, but to ask better questions. What sources did the cartographer have access to? How old were those sources? What was copied faithfully and what was adapted? What information survived because it remained useful, even when its origin was forgotten? These questions do not undermine science. They expand it. They also align with everything we have seen so far. Footprints that appear too early, tools that arrive ahead of schedule, cities that precede agriculture, monuments encoding knowledge without writing, myths preserving fragments of catastrophe, silent gaps erasing continuity. Ancient maps fit into this pattern naturally. They are artifacts of transmission, not invention. And transmission implies movement, people moving along coasts, along rivers, across seas, carrying stories, skills and references that outlasted their settlements. At certain points in the historical record, something strange happens. A culture appears that does not seem to grow out of what came immediately before it. There are no obvious prototypes, no long trail of experimentation preserved in the ground, no gradual ramp-up that we can point to with confidence. Instead, there is a sudden presence, organised settlements, distinct art, established technologies, social structures that look as though they have already been tested elsewhere. To historians and archaeologists, this is deeply uncomfortable. Science prefers continuity. Even when progress is uneven, it usually leaves behind stepping stones. Earlier versions, failed attempts, transitional phases. When those are missing, the instinct is to assume they must exist somewhere, undiscovered, misdated, or misunderstood. And often that instinct is correct, but not always. There are civilizations that enter the archaeological record with such confidence and coherence that even after decades of research, their origins remain frustratingly opaque. Not mysterious in a sensational sense, but incomplete in a structural one. We can describe what they were. We can document what they built. We can trace how they declined. What we struggle to do is explain how they got there. One of the most frequently cited examples is the civilization of ancient Sumer. Located in southern Mesopotamia between the Tigris and Euphrates rivers, Sumer is often described as the first civilization. It appears in the archaeological record around the late 4th millennium BCE, with cities, writing, complex religion, advanced irrigation, and administrative systems already in place. That description alone should raise questions. Writing does not emerge overnight. Urban planning does not emerge overnight. Legal codes, accounting systems, standardized measurements, monumental architecture, and layered religious cosmologies do not simply materialize without a long period of development. And yet, the earliest Sumerian cities show all of these features in recognizable form. There were earlier cultures in Mesopotamia. The Ubaid culture, for example, preceded Sumer and shows signs of increasing complexity. But the jump from Ubaid settlements to full Sumerian urban life is steep. The scale, speed, and coordination involved are difficult to reconcile with a simple linear progression. The Sumerians themselves claimed their civilization was bestowed by gods. Kingship descended from heaven. Knowledge was revealed, not invented. From a modern perspective, this is mythology, but from an anthropological one it may reflect something else, a recognition that their system did not feel locally derived. Another case appears on the other side of the world in the Indus Valley. The Indus Valley civilization, centered around cities like Harappa and Mohenjo-daro, emerges around 2600 BCE with remarkable sophistication. Its cities are laid out on grids, streets are straight, drainage systems are advanced, bricks are standardized, urban planning is consistent across vast distances, and yet the ancestors of this civilization remain elusive. There are earlier cultures in the region, but none that clearly explain the sudden emergence of such uniformity and organization. The Indus script remains undeciphered, which further complicates matters. Without written records we can read, the internal story of development is silent. What makes the Indus Valley particularly striking is what it lacks. There are no obvious palaces, no large temples, no monumental tombs, no clear evidence of kings or centralized authority. And yet, the cities function smoothly. Sanitation systems were maintained, trade networks extended far beyond the region. This suggests a social system that worked very well, but left little ideological noise behind. No grand propaganda carved into stone, no rulers insisting on eternal remembrance. When such a civilization disappears, as the Indus Valley did, it leaves behind infrastructure without explanation, order without narrative, presence without ancestry. In South America, a similar pattern appears with the Norte Chico civilization, also known as Caral Soup. Located along the arid coast of modern Peru, this civilization dates back to around 3000 BCE, making it contemporaneous with early Egypt and Mesopotamia. It features large platform mounds, sunken plazas, and planned settlements. Agriculture was present, but protein came largely from fishing. There is no evidence of pottery, writing, or warfare. Again, the problem is not that this civilization existed. It clearly did. The problem is that it appears fully organised, without obvious precursors showing the gradual development of its architectural and social systems. Norte Chico does not look like a rough experiment. It looks like a mature solution to living in a challenging environment. And then there is ancient Egypt. Egyptian civilization does have predecessors, but the speed with which it coalesces into a unified state is striking. Within a relatively short period, Egypt develops monumental stone architecture, a complex religious system, advanced mathematics, medicine, and writing. The earliest pyramids appear not as crude prototypes, but as ambitious projects that already assume deep knowledge of stoneworking, surveying, and logistics. There are earlier mastabas and experiments, yes, but the leap remains significant. The Egyptians themselves spoke of a time before dynasties, a mythical era when gods ruled directly. Again, mythology does not equal history, but it reflects an awareness of discontinuity. China presents its own version of this pattern. Early Chinese civilization emerges with sophisticated bronze casting, ritual systems and writing during the Shang dynasty. The level of metallurgical expertise required is immense. Bronze casting at this scale requires resource coordination, standardized processes, and skilled specialists. Yet the path leading up to this mastery remains partially obscured. Earlier cultures existed, but the emergence of such complex bronze technology appears rapid. In each of these cases, the issue is not that archaeologists have found nothing. It is that what they have found does not fully explain the outcome. Civilizations with no clear ancestors are not evidence of outsiders or lost super technologies. They are evidence of missing context. That context may have existed in forms that did not preserve well. Wooden structures, textile traditions, oral institutions, seasonal gathering sites, coastal settlements now underwater. All of these could support long-term cultural development without leaving dense archaeological footprints. It may also be that development occurred elsewhere, and the civilization we see is the result of migration or convergence. Knowledge does not always develop where it is expressed. People move, ideas move faster. If a group with established social systems relocates into a new region, they may appear suddenly in the archaeological record, even though their development occurred elsewhere. This is particularly plausible in river valleys and coastal plains, where migration routes converge. Another factor is scale bias. Small-scale societies can be highly complex without producing large, durable structures. Their complexity exists in social rules, kinship systems, and knowledge transmission rather than in architecture. When such societies grow or consolidate, their material footprint expands rapidly, creating the illusion of sudden emergence. Collapse, then, erases the smaller steps, leaving only the peak. Science increasingly recognizes this pattern. Terms like punctuated equilibrium, borrowed from evolutionary biology, are sometimes applied cautiously to cultural development. Long periods of relative stability are interrupted by rapid change. The change looks abrupt because the slow groundwork was invisible. There is also the role of environmental windows. Certain climatic conditions make large-scale organization easier. Stable rainfall, predictable seasons, abundant resources. When such windows open, societies that have been developing quietly can expand quickly. When the window closes, they contract or vanish. From the outside, it looks like appearance and disappearance. From the inside, it feels like opportunity and loss. Civilizations with no clear ancestors may therefore represent moments when multiple threads came together at once. Population density reached a threshold. Knowledge networks overlapped. Environmental conditions aligned. What followed was not a miracle, but a release of potential. Still, the discomfort remains. Because even when all of this is acknowledged, there are cases where the evidence simply does not line up neatly, where the sophistication seems ahead of schedule, where the absence of transitional phases is not easily explained by preservation alone. Science does not fill those gaps with certainty. It marks them as open questions, and open questions matter. They remind us that our timelines are provisional, that our confidence should be proportional to our data, that history is not a closed book, but a working draft. The idea of civilizations with no clear ancestors challenges a comforting assumption that progress is always traceable, that every outcome has a visible lineage, that nothing important is ever truly lost. The evidence suggests otherwise. Human societies appear capable of developing complexity, losing it, and redeveloping it under different conditions. Knowledge can be preserved unevenly. Social systems can vanish while technologies survive, or technologies can vanish while symbolic structures persist. This does not diminish modern civilization. It places it within a longer, more fragile story. A story where what survives is not always what mattered most. There is a moment in every scientific investigation where confidence gives way to restraint, where data stops forming a clear picture, where hypotheses multiply instead of converge, and where the most responsible answer becomes a quiet, deliberate pause. We don't know yet. This moment is rarely emphasized outside academic circles. It does not make for dramatic headlines or satisfying conclusions, but it is one of the most important features of science as a method, not as an institution, not as a body of facts, but as a way of engaging honestly with reality. When it comes to the lost stretches of human history, that pause appears more often than many people realize. Despite centuries of archaeology, decades of advanced dating techniques, and the recent explosion of genetic and environmental data, there remain fundamental questions that science cannot currently answer with confidence. Not because the questions are poorly framed, but because the evidence required to answer them no longer exists, has not yet been found, or may be impossible to recover. One of the most basic unanswered questions is scale. How many humans lived on Earth before the last ice age ended? Estimates vary widely. Population numbers depend on assumptions about carrying capacity, climate stability, and technological adaptation. Small changes in those assumptions produce radically different results. If coastal environments supported dense populations for tens of thousands of years, and if those coastlines are now submerged, then global population estimates for deep prehistory may be significantly underestimated. Science can model possibilities, it cannot confirm them. Another unresolved question concerns continuity. Did human societies repeatedly collapse and rebuild using fragments of previous knowledge, or did most innovations truly arise independently each time? The evidence supports both interpretations in different contexts. Some technologies appear to be reinvented multiple times. Others show signs of diffusion. Untangling those patterns is extraordinarily difficult when the archaeological record is incomplete. We know humans are capable of rediscovery. We also know knowledge can persist quietly for generations. Distinguishing between those two processes thousands of years later is often impossible. Then there is the question of social complexity. How complex were human societies before agriculture became widespread? The traditional model assumes small, egalitarian bands with limited coordination. Yet mounting evidence suggests that some pre-agricultural groups organised large gatherings, built monumental structures, managed resources seasonally, and maintained shared symbolic systems over long periods. What science cannot yet explain is how widespread this complexity was. Were these rare exceptions driven by unique environmental conditions, or were they part of a broader pattern that left little trace? Without written records or durable materials, Complexity expressed through social rules and rituals may be archaeologically invisible. Science can identify the exceptions. It cannot yet map the norm. Another area of uncertainty involves migration. We know humans migrated extensively. We know they crossed continents and oceans earlier than once believed. What remains unclear is how often these movements occurred, how organised they were, and what technologies supported them. Simple watercraft can travel remarkable distances under the right conditions. Coastal navigation does not require stars or compasses, only familiarity with currents, winds, and landmarks. Such knowledge could spread quickly and leave almost no material trace. Science can infer migration routes from genetics and tool distributions. It cannot reconstruct the lived experience of movement, how knowledge was transmitted, how risks were managed, how routes were remembered. These gaps matter because migration shapes everything else. Social organisation, technological diffusion, and cultural memory all depend on how people move through the world. There is also the unresolved issue of time perception. How did early humans understand time, cycles, and long-term change? We know they observed celestial events. We know they tracked seasons. We know some monuments encode astronomical knowledge. What we do not know is how this understanding shaped decision-making at a societal level. Did long-term environmental awareness influence settlement choices? Did it inform strategies for dealing with climate instability? Did it allow some groups to anticipate change better than others? Science can detect the outputs of such knowledge, but not the internal reasoning behind it. Another major uncertainty lies in loss. How much knowledge was lost permanently? This is perhaps the hardest question of all, because it is inherently unanswerable. We cannot count what did not survive. We can only observe that loss occurred. We know languages vanish without trace. We know skills disappear when conditions change. We know entire ways of life can end within a generation. Multiply that by thousands of years and countless societies, and the scale of potential loss becomes staggering. Science can document extinction. It cannot quantify absence. There are also questions surrounding technological ceilings. Were there technologies that early humans experimented with and then abandoned because they were unsustainable, inefficient, or incompatible with changing environments? Not advanced machines in a modern sense, but techniques, materials, or systems that did not persist. The archaeological record favours what worked long-term. Failed innovations leave fewer traces, yet failure is a crucial part of experimentation. Without knowing what was tried and discarded, our picture of technological development is incomplete. Then there is the matter of interpretation itself. Science relies on models. Models simplify reality to make it understandable. When evidence fits poorly, models are adjusted. But models also shape what questions are asked and what evidence is considered relevant. For decades, the assumption that agriculture preceded social complexity guided interpretation. Evidence was filtered through that expectation. Only recently has the model begun to loosen. Science now admits that earlier frameworks may have obscured important patterns. That admission does not invalidate past research. It highlights the evolving nature of understanding. There are also methodological limits. Radiocarbon dating, while powerful, has margins of error. Contamination can skew results. Calibration curves change as new data emerges. Dating organic material associated with stone structures often relies on indirect association, which introduces uncertainty. Genetic data offers incredible insight, but it too has limits. It reflects surviving lineages, not extinct ones. Cultural practices do not map neatly onto genetic markers. Population replacement can erase genetic continuity even when cultural influence persists, or vice versa. Environmental reconstructions rely on proxies. Pollen, isotopes, sediment layers. These are interpretations, not direct observations. Science is transparent about these limits, but they are often overlooked outside specialist discussions. Perhaps the most profound uncertainty concerns meaning. Why did early humans build what they built? Why did they organize space the way they did? Why did certain symbols recur while others vanished? Science can identify patterns. It cannot fully access intention. This is not a failure of rigour. It is a boundary between material evidence and lived experience. When science admits it cannot explain something yet, it does not imply that explanation will never come, but it does imply humility. And humility is essential when dealing with deep time. The lost chapter of human history is not lost because it is forbidden or hidden. It is lost because the conditions that preserve stories are rare, because catastrophe erases context, because human societies do not always leave durable signatures, because the Earth is an active participant in forgetting. Science acknowledges this. It acknowledges that our current narrative is provisional, that new discoveries regularly force revision, that certainty decreases as we move deeper into the past. This acknowledgement is not weakness. It is strength. It allows room for multiple hypotheses without committing prematurely. It resists sensational conclusions while remaining open to surprise. It recognizes that not knowing is sometimes the most accurate position available, and it reframes curiosity. Instead of asking, "What did we miss?" science increasingly asks, "What conditions would produce what we see?" Instead of searching for singular explanations, it explores systems, interactions between climate, geography, culture, and time. This approach does not promise neat answers. It promises better questions. Those questions lead naturally to reflection. Why are some gaps so hard to see? Why do certain ideas feel threatening? Why is the notion of forgotten complexity uncomfortable? Part of the answer lies not in the past but in the present. Modern societies rely heavily on the assumption of progress, that we are smarter, more capable, and more informed than those who came before, that our trajectory is upward. Acknowledging deep uncertainty challenges that assumption. It suggests that intelligence and ingenuity are not new, that vulnerability is constant, that collapse is possible. Science does not shy away from this implication, but it also does not dramatize it. It simply notes that history is not a straight line. Sometimes the hardest things to notice are not hidden. They are right in front of us, blended so thoroughly into what we expect to see that they become effectively invisible. This is one of the quiet paradoxes of human perception. We are remarkably good at finding what we are looking for, and equally good at overlooking what does not fit the shape of our expectations. When it comes to the lost stretches of human history, this matters more than we often admit. The difficulty is not simply that evidence is scarce or fragmentary, though it often is. The deeper challenge is that our frameworks for understanding the past were built under assumptions that feel natural, logical, and almost self-evident. Those assumptions influence what questions we ask, what answers we consider plausible, and which anomalies we treat as noise rather than signal. In other words, this chapter may be hard to see, not because it is deliberately obscured, but because we were not trained to look for it in the first place. Modern historical thinking developed alongside modern institutions. Universities, archives, museums, and disciplines all emerged within societies that valued written records, permanent architecture, and linear progress. It makes sense, then, that history came to be defined by texts, monuments, and dates that could be arranged neatly along a timeline. Prehistory, by contrast, was long treated as a prelude, a vague background hum before the real story began, something to summarize rather than explore in depth. That framing still echoes today. When people imagine ancient complexity, they picture cities, writing, and states. Anything that does not resemble those features feels incomplete or primitive by default. But this is a cultural bias, not a biological one. Human intelligence did not suddenly switch on with the first brick or inscription. It was always there, expressed through whatever forms the environment and social structure allowed. One reason this chapter is hard to see is that complexity does not always leave durable traces. A society organized around seasonal movement, oral knowledge and shared ritual may be extraordinarily sophisticated, yet archaeologically faint. Its buildings are temporary, its tools are organic, its laws are spoken, not written. Its history lives in memory rather than stone. From a modern archival perspective, such a society barely exists. This creates an illusion of absence, not because nothing happened, but because what happened did not survive in forms we're accustomed to recognizing as evidence. There is also a bias toward permanence. We tend to value what lasts. Stone over wood, writing over speech, cities over camps. This bias shapes interpretation. When archaeologists uncover monumental remains, they receive attention. When they uncover subtle patterns of land use, temporary structures, or scattered artifacts, those findings often struggle for recognition, yet permanence is not the same as importance. Many human achievements are deliberately impermanent. Rituals end, gatherings disperse, knowledge is carried in people, not places. When those people move or die, the record evaporates. Another reason this chapter is hard to see lies in how scientific disciplines are divided. Archaeology, climatology, genetics, anthropology, linguistics, and mythology often operate in parallel rather than in true integration. Each field has its methods, standards, and limitations. Each answers different questions. The lost chapter lives in the spaces between them. Climate science can tell us when environments changed, but not how societies responded culturally. Genetics can tell us about population movement, but not about beliefs or social organisation. Archaeology can uncover structures and tools, but not the meanings attached to them. Mythology can preserve echoes of experience, but not precise mechanisms or dates. Seeing the full picture requires synthesis, and synthesis is difficult. It requires comfort with uncertainty. It requires resisting the urge to privilege one type of evidence over all others. It requires acknowledging that no single discipline holds the key. This is not how most education systems train us to think. Another obstacle is narrative simplicity. Human brains are storytelling machines. We prefer clean arcs. Beginnings, middles and ends, heroes and breakthroughs, clear causes and effects. History textbooks reflect this preference. They compress complexity into digestible sequences. The idea that human development involved repeated advances and losses does not fit neatly into that structure. It complicates the story. It resists summarization. As a result, it often gets smoothed over. We say agriculture began here, rather than agriculture emerged, retreated, re-emerged, and spread unevenly over thousands of years. We say cities arose, rather than dense settlements formed, collapsed, reformed, and took different shapes depending on conditions. These simplifications are not lies, they are tools. But tools can obscure as much as they reveal. There is also a psychological discomfort involved. Acknowledging that complex societies may have existed and vanished before recorded history challenges a subtle but powerful belief that we are the inheritors of an unbroken chain of progress. That knowledge accumulates reliably. That collapse is an anomaly rather than a recurring feature. This belief underpins much of modern confidence. Letting go of it does not mean embracing pessimism. But it does require accepting vulnerability. It requires recognizing that intelligence does not guarantee stability. That knowledge can be lost. That civilization is not an endpoint, but a condition that must be continuously maintained. This is not an easy realization. It is far more comforting to believe that we are smarter because we are later, that our ancestors were less capable because they came before. That time itself confers improvement. The evidence does not support that comfort. Another reason this chapter remains difficult to see is that it does not announce itself loudly. There is no single artifact, no definitive site, no dramatic discovery that forces immediate revision of the entire narrative. Instead, there are many small tensions, dates that don't quite align, structures that seem too early, tools that appear ahead of schedule, myths that echo across cultures. Each one can be explained individually. Each one can be contextualized. It is only when viewed together that a pattern emerges. Patterns are harder to defend than objects. They require interpretation. They invite debate. They resist certainty. As a result, they move slowly through academic consensus. This is not a flaw. It is a safeguard. Science advances carefully, because history is littered with confident theories that later proved wrong. Skepticism protects against error. But skepticism can also delay recognition when evidence accumulates incrementally rather than explosively. There is also the problem of scale mismatch. Human history spans hundreds of thousands of years. Written history spans a few thousand. Modern scientific inquiry spans a few centuries. Our intellectual tools evolve to handle short time scales well. Deep time stretches those tools. It becomes difficult to intuitively grasp processes that unfold over millennia, punctuated by sudden events that reset local conditions. We default to linear models because they are cognitively manageable. But deep time is non-linear. Climate changes abruptly. Populations fragment and recombine. Technologies appear, vanish, and reappear. Knowledge spreads unevenly. Seeing this requires stepping outside everyday intuition. Another subtle obstacle is language itself. Words like civilization, progress, primitive, and advanced carry assumptions. They imply value judgments. They suggest hierarchy. They encourage comparison rather than understanding. When early societies do not fit these categories, they become hard to classify. If they are not agricultural, not urban, not literate, then where do they belong? Often, they are placed in a catch-all category of pre-civilized, which implies deficiency rather than difference. This linguistic framing makes it harder to recognize complexity that takes unfamiliar forms. There is also the influence of modern technology on perception. We live surrounded by machines, infrastructure, and systems that feel overwhelmingly complex. Compared to this, ancient societies appear simple by contrast. But this is an illusion created by specialization. Modern complexity is distributed. No single individual understands the entire system. Ancient complexity was often integrated. Knowledge was embedded in practice, ritual, and environment. It was not abstracted into manuals or databases. That makes it harder to see from the outside. Imagine trying to assess the sophistication of a society based solely on what remains after most of its materials have decayed. The picture will always be incomplete. This incompleteness becomes even more pronounced when combined with catastrophe. Floods erase coastlines, ice grinds landscapes, fire sterilizes regions. When these forces act repeatedly, they do not just remove evidence, they selectively remove certain types of evidence. What survives are the outliers, the unusually durable, the accidentally preserved, the everyday disappears. This creates a distorted archive. When we then ask, why don't we see evidence of earlier complexity? The answer may be that we are looking in the wrong places, with the wrong expectations at the wrong scale. Science is increasingly aware of this, but awareness does not immediately translate into clarity. Underwater archaeology is still limited. Vast submerged landscapes remain unexplored. Genetic data continues to revise migration timelines. Climate models grow more precise, revealing instability where stability was assumed. Each advance helps, but none offers a complete picture. And perhaps that is the most important reason this chapter is hard to see. It is not a single chapter. It is a pattern of interruption, a recognition that human history is not a smooth narrative but a series of attempts, some successful, some short-lived, some erase so thoroughly that we mistake absence for simplicity. Seeing this requires patience. It requires resisting both sensationalism and dismissal. It requires holding uncertainty without rushing to fill it. It requires accepting that some questions may remain open indefinitely. That is not failure, it is honesty. As science continues to refine its tools and expand its scope, parts of this chapter will come into sharper focus. Others will remain blurred. New evidence will complicate old models. Old assumptions will quietly dissolve. And through it all, the most important shift may not be in what we discover, but in how we interpret discovery itself. Because once we accept that human history includes deep gaps, repeated losses, and forgotten complexity, our relationship with the past changes. It becomes less about finding a single missing piece and more about recognizing a different kind of story. A story not of inevitable ascent, but of persistence. To be standing here now is to occupy a very narrow ledge between what is remembered and what is forgotten. We tend to think of the present as solid, self-evident and permanent, but from a wider view, it is just another thin layer settling briefly on top of everything that came before. Beneath it lie countless other presents, once just as vivid, just as certain, now compressed into fragments, gaps, and silence. When you step back and consider that perspective, something subtle but important changes. The lost chapter of human history stops feeling like a puzzle to be solved and starts feeling like a condition of being human. We're not standing at the end of a long, clearly marked road. We're standing in the middle of a field where many paths have crossed, faded, reappeared and vanished again. Some of those paths led to cities, some led to coastlines now underwater, some led nowhere and ended quietly when conditions changed. All of them were walked by people who felt as present in their moment as we do in ours. That realization can be unsettling at first. Modern life trains us to think in terms of accumulation. More data, more technology, more records, more certainty. We are surrounded by storage systems designed to preserve everything. Photos, messages, documents, backups of backups. It creates the impression that forgetting is optional, that loss is a failure rather than a natural process. Human history does not support that impression. Most of what mattered to most people who ever lived is gone. Not hidden, not waiting to be rediscovered, simply gone. Their voices, routines, decisions, fears, and hopes dissolved when the conditions that sustain them dissolved too. Standing here now means accepting that this will also be true of us. That does not make the present meaningless. It makes it fragile. Fragility changes how responsibility feels. If knowledge can be lost, then preservation becomes an active choice rather than a passive assumption. If societies can collapse quietly, then stability becomes something to tend, not something to expect. If progress is reversible, then humility becomes as important as confidence. One of the most striking lessons of the lost chapter is that intelligence alone does not guarantee continuity. Early humans were observant, adaptive, and capable. They tracked the sky. They navigated coastlines. They organized large groups. They encoded knowledge in stone, ritual, and story. And still, much of that knowledge vanished. Not because it was wrong, because the systems that carried it broke. Standing here now means recognizing that our own systems are not exempt from that vulnerability. They are larger, faster, and more interconnected, but also more dependent on conditions remaining within certain bounds. Climate stability, resource availability, social trust, communication networks. When those conditions strain, complexity becomes harder to maintain. This is not a prediction. It is an observation grounded in history. Another implication of standing here now is that the past is not finished with us. Not in a mystical sense, but in a structural one. Our understanding of ourselves is built on narratives about where we came from. When those narratives shift, identity shifts with them. If early humans were more capable than we once believed, then modern intelligence is not a sudden peak. It is an expression of a long-standing capacity. If societies have risen and fallen repeatedly, then permanence is not a defining feature of civilization. It is an aspiration. That reframing alters how we see achievement. Instead of viewing ancient structures as primitive precursors to modern engineering, we can see them as solutions optimized for their contexts. Instead of seeing early societies as incomplete versions of us, we can see them as complete versions of themselves, operating under different constraints. Standing here now means loosening the instinct to rank the past. It also means rethinking what counts as success. History books often celebrate expansion, dominance, and longevity. But those metrics are biased toward what leaves the biggest traces. They overlook quieter forms of success, sustainability, balance, adaptation, knowledge that worked well enough not to need escalation. Some early societies may have thrived precisely because they did not push toward permanence or growth. When conditions changed, they moved. When resources thinned, they adjusted. Their flexibility may have kept them alive longer than rigid systems that collapsed dramatically. From our perspective, those societies look like gaps. From theirs, they were lives fully lived. Standing here now invites a different kind of curiosity, not just about what was lost, but about what was chosen, what paths were taken deliberately, what forms of knowledge were prioritized because they mattered day to day, not because they would impress distant descendants. This matters because modern society often assumes that what lasts longest is what matters most. Stone over story, monument over memory, archive over experience. The Lost Chapter challenges that assumption. It suggests that much of what sustains human life does not fossilize well. Cooperation, empathy, practical wisdom, situational awareness, the ability to read landscapes, people, and change. These are skills passed through presence, not permanence. Standing here now means recognizing that our own era will be judged, if it is judged at all, through a similarly distorted lens. What survives will not be a fair representation of what mattered most to us. It will be what happened to endure. Another subtle implication concerns certainty. Modern knowledge systems often aim for closure. A problem is solved, a theory is confirmed, a timeline is finalized, but deep history resists closure. New evidence keeps reopening questions. Old assumptions keep softening. Standing here now means living with that openness. It means accepting that not knowing is not a temporary flaw, but a permanent feature of engaging with deep time. The farther back we look, the more interpretation outweighs documentation. The more humility becomes necessary. This does not weaken science, it refines it. Science that acknowledges its limits is more trustworthy, not less. It is less likely to overreach, less likely to confuse plausibility with proof, more likely to adapt as new information appears. The Lost Chapter reinforces this approach. It reminds us that explanations should remain provisional, especially when dealing with incomplete records shaped by erosion, catastrophe, and chance. Standing here now also affects how we relate to myths, traditions, and alternative ways of knowing. This does not mean abandoning critical thinking. It means recognizing that different systems preserve different kinds of information. Oral traditions may preserve emotional truth. Ritual may preserve ecological knowledge. Symbol may preserve relationships rather than facts. None of these replace scientific analysis, but they complement it. When science listens without surrendering rigor, it gains context. When it dismisses too quickly, it risks missing patterns that only emerge across disciplines. Standing here now means holding multiple perspectives at once, without forcing them into premature agreement. There is also a personal dimension to all of this. When you consider the depth of human time, individual worries often soften, not disappear, but reposition. The pressures of daily life exist within a much larger frame. That frame does not diminish their reality, but it changes their scale. People before us faced uncertainty without guarantees. They adapted without knowing what the next season would bring. They raised children without assuming stability. They found meaning without permanence. Standing here now means inheriting that same condition, even if modern life sometimes disguises it. This perspective can be grounding rather than frightening. It reminds us that adaptability is not new, that uncertainty is not a failure state, that resilience has always been part of the human story. It also encourages attentiveness. If much of history is lost because it left no durable trace, then presence itself becomes valuable. Paying attention, noticing patterns, listening to environments, responding thoughtfully to change. These are not abstract virtues, they are survival skills honed over millennia. Standing here now means participating in that lineage, whether we think about it consciously or not. The lost chapter does not ask us to mourn what we cannot recover. It asks us to reconsider what we prioritize, what we preserve intentionally, what we assume will take care of itself. It also asks us to be cautious with certainty about the future. Just as past societies could not foresee all the forces that would reshape their world, we cannot fully anticipate ours. That does not mean planning is futile. It means flexibility matters as much as foresight. History, when viewed through this wider lens, becomes less about triumph and more about continuity through change. Less about domination and more about adaptation. Less about answers and more about attentiveness. Standing here now is not a conclusion. It is a position, a moment of awareness between what has been forgotten and what has not yet happened. A reminder that we are not the first to wonder how much came before, and we will not be the last to leave questions behind. And perhaps that is the quiet continuity running through the entire story. Not a single civilization, not a single technology, not a single chapter that survives intact, but a repeating human impulse to look around, notice patterns, ask questions, and try to understand where we are. That impulse appears in footprints pressed into ancient mud, in tools shaped by careful hands, in stones aligned with the sky, in stories passed from voice to voice, in maps copied long after their sources were forgotten, in pauses where science admits uncertainty, and in the present moment, wherever you are listening now. To be standing here now is to be part of that ongoing attempt, not at the end of the story, not at the beginning, just here for a while, carrying what we can, noticing what we can, and adding one more thin layer to a history that was never meant to be complete.